Thank you very much indeed, and welcome to the AGM, both to those of you in the auditorium at the Institute of Physics and also to those watching on YouTube as well. So it's great to actually be face-to-face again with members, something which we haven't been able to do. I think the last meeting was back in Hull in was that 2020, yeah. So, without further ado, if I can introduce the minutes to start with. The minutes have been on the website, just above the agenda on the website, and also been displayed out in the tea room. Is there anybody who within the hall who wants to question anything with regards to the minutes from last year? Excellent. So that will pass through or accept those minutes as approved. So moving on to the adoption of the accounts. If I can ask Jeff to we've got some slides there, so if you'd like to come up to the lectern and you can move them forward using that.
Okay, so before I forget, the people in the room can obviously ask questions directly. Those of you that are listening or watching on YouTube, you can somehow write questions.
They can either write questions. I'll do this properly. Yeah, so if anyone needs to ask any questions, they can either type into the comments on YouTube or they can put it into the BAA forum chat, and I will read the questions out and then you can answer them.
Very good. Thank you, Nick. Okay, so the financial results have been made available on the BAO website. Their entire thing, there's 24 pages of closely argued monies, and the important extracts were put in the recent journal. Okay, so you should all have been able to look at them up to now. However, I'm going to go through some more important facts and then see what you say. So, from a financial point of view, notwithstanding the pandemic and so on, we have had a very successful year. Our total reserves have increased by over £210,000. Now, remember last year, they went down by 134,000 because the stock market dropped out of the sky, but now it recovered and we've gone ahead. So at the end of the year, and the end of the year was the end of March, we had total reserves of £1.6 million. We need to spend some money, right? And looking at the numbers as of last night, they have continued to increase by another £150,000. Now, we're not going to have all that by the end of the year, so we'll get some expenses, but we will be pretty well off. So those look good, but the underlying details do reveal a problem, and that problem needs addressing, and we're going to talk about that later, exactly what that is and how it's being addressed. But here you can see, we got £210,000 down here as our net movement of funds. Our investments went up by £262,000, but we had an operational loss of £82,000. So I said, you don't include bequests, you don't include investment income, just running the business, we lost £82,000 in a 12-month year, 9 months, 56, 12 months before that, 84. So we're running a loss of £6,500 to £7,000 a month consistently for the last few years. That needs addressing. And Alan's going to actually address that, unless someone actually wants to know the answers. So there we are, that's the big red line. And that's really all I'm going to talk about now, except to come up with the summary, which, there we are, total gain, we said 210,000, investment gain 260, but we've got bequests came in at 30,000. So you take all that into account and we lost £83,000 almost. But our reserves going forward were 1.6 million. Tangible assets, that includes the instrument collection and the computers, the desks, all that sort of stuff. So in money, we've got just over £1.5 million in easily accessible cash. And that's all I want to say about them, unless someone wants to ask a question right now, because I have one more thing to say. We will be putting an announcement about the following into a forthcoming journal, but so that you people who are interested in the association get first dibs on the job, you'll have noticed in the voting form that I am standing, and hopefully I've been elected, to treasurer for one more year. But at this time next year, I'm standing down. So it does give one of you, or one of your friends, the opportunity to get involved in the detailed running of the association. Everyone's staring at their shoes. Okay, that's all I have to say. But if there's no questions coming, Nick?
I have no questions.
Okay, there's been, as far as I can see, no questions here, so I'll pass it back to Alan. Thank you, Alan. That's forward.
Thank you very much indeed, Jeff. That you haven't been sort of had your hand bitten off on that one, have you? That's a great offer, but we will be looking for a new treasurer for next year. So if we move forward, I think. Okay. Well, it's nice to be actually in front of people again. So the year's obviously been sort of different from preceding ones, but not too different from 2020. We've had all our meetings cancelled, and this is obviously the AGM, so it was important to us to actually try and get restarted as far as face-to-face as quickly as possible. That's not going to work, is it now? Okay. Right, to start with, again, I started with this last year, and unfortunately we have lost a significant number of people again. Not quite as many as last year. We don't have a sort of an understanding of how many were COVID. We just learn that we've lost the members, but so it's been another year where we've lost members, and just recently we've lost another one. It's Fiona Vincent, who was, I know, part of the Aurora and up in Scotland. That was another sort of colleague who has been lost. In Scotland, we also had Ron Liversley. That last year, this was I think taken at the exhibition meeting to the Aurora section. That Ron was sadly missed. That was the Lydia Brown Medal winner in 1995 and the Water Goodacre medalist in 2012. He died in February. That he was a regular solar observer as well as section director for the Aurora section. Peter Bosley. Peter passed away in the end of April this year. That it was a shock that she was a serving member of both council and of the association's board. And I remember receiving on walks of one morning when an email came out of blue from Steve, who was also on the council, to say that Peter had passed away. So yes, a loss to us there. So our thoughts are with the friends and families, not only of those that I've mentioned, but also of those members who have died over the last 12 months. So coming on to the board and council, we continue to meet on a virtual basis. That the workings of the association need to continue. So the exception being today, so it's the first time we've been able to meet face to face. So each year we have a council photo, and it used to be, I remember when we first came to, I was first treasurer, that everybody, Hazel McGee used to herd us all out onto these steps, not onto steps. We did the steps once at Bellington House, but onto the stairs, the internal ones, and the picture of the wonderful windows there. So this again is was our council picture for this year. That another one on Zoom, which will be added to the collection for the archives. And yes, let's hope that next year we can do it face to face. So I'd like to thank everybody for the okay, right, go back one slide. To thank everybody for their time and effort in doing the works of the association. And I said this at council this morning, but I also think it's appropriate to mention it to the membership as a whole. From the board, that Callum Potter, past president he's been vice president for the last 2 years, so he will be standing down as I take over that role. And Nick Hewitt is also standing down, and Tim Parsons from the board. And from council, thanks David Boyd, who done a considerable stint on council as well, Elliot Hall, and Stephen Bosley, following Peter's death, has decided to stand down from council as well. So thank you to all for your help over the last, for me, for the couple of years and over the last year in particular. Now, this is a topic, the instrument collection recovery. As reported in this month's journal, regrettably, over the last few years, there has been an ongoing dispute with regards to various items which were astronomical equipment that form part of the heritage instrument collection within the association. And regrettably, despite best endeavours, this culminated in the association having to take legal action in the county court to recover these items from the former curator of instruments, Bob Marriott. So that was the action that we took, and in a court ruling on the 2nd of September this year, the judge confirmed the BAA's ownership of all significant items in dispute, as well as awarding costs in the proceedings to the association as well. So I really just want to thank our legal team, who've taken a lot of effort in doing this and bringing this sad affair to a conclusion. So thank you very much. To happier things almost, the office. It's not a flashback in time. This is our office that I know that many of you will have visited many times, Burlington House, which has been our home in conjunction with the RAS, or the RS home, but we have sort of cohabited for the last 75 years. So the office staff have been working remotely for the past 18 months from the first, the first lockdown in March 2000, and the cost of retaining the physical office, if you've done your homework and been reading Jeff's accounts in detail, you will have seen that we spend in the region of around £35,000 a year to utilise the Herschel room, which is the office upstairs in Burlington House, use of the council room for our council meetings, and the relatively small theatre downstairs, which many of you will have watched presentations in over the years. Quite frankly, with the relocation of the office onto a virtual basis, the need to be spending that amount of members' subscriptions has diminished to the point that we couldn't hand on heart say that this was a good way of spending the money. And on this basis that we passed a motion, or motion was passed at council in September. It was confirmed by the board in October, and we've subsequently written a letter which will be published, I think published in the journal, which gives basically the outline that of our rationale for leaving, which we've explained to the RAS, and they are fully understanding of that. It is purely a financial decision that we cannot justify your subscriptions going to that. So from the end of January, we will be giving up the use of the facilities at Burlington House, but also we will not be spending that money on it. We have expressed to the RAS that it's our desire to maintain fully our contact with them and to work in collaboration with them. And within the letter, we've made specific reference to working with them to try and to promote diversity within astronomy and also to work on pro-am projects as well. So we very much want to work together with them rather than severing our going our different ways. And it may well be that some of you may be aware that there is currently a discussion with the government about the rent which is charged to the RAS, of which at the moment we pay a 10% portion. But the government have really said that, Mr. Johnson has said that they've been made a very generous offer already, and so it may well be that at some point in the future the RAS will and the other learned societies will need to consider their position. It is hoped, in order to retain a degree of contact with the RAS and Burlington House in particular, that we will retain our registered office and also our postal address there. So we will still have Burlington House on our sort of letterhead, but in actual fact, as of now, nothing gets sent there. It all gets directed to the virtual office. Okay, so that's really from an admin point of view. The journal is another 6. I've pulled off the covers of the journal each time. They're getting sort of let's say more attractive. I would hope to say that Philip Jennings has been in role as journal editor for a while now, and is bringing to it his own perspective and his own personal touch to the publication. I'd also like to thank Mary-Louise Archer, who has taken on the role of advertising manager. And some of you will have noticed within your journal for October the full page advertisement of, I think it's First Light Optics. So it's one that she's brought on board. So we're trying to involve the sort of the wider astronomical community and get them, and also get some revenue as well. I would also like to thank Jeremy, Professor Shears, for all his work as paper secretary. It's all the work that he does with dealing with the people who write them and talking to them and dealing with the referees. There's an awful lot of work that goes on behind the scene before it actually gets put into the format that we see in the journal. I would also like to. This has come up following sort of let's say a comment made by a member over the last week, in that the October journal seems to have been particularly late in being received, and was this a deliberate attempt to get everybody to go on to onto digital membership? And I would categorically like to say to everybody, no, there is not some hidden conspiracy theory behind it. We are intending to retain the journal in a paper format for the foreseeable future. It is intended to arrive at the beginning of each month, as near as possible. Unfortunately, the logistics as far as the pandemic is concerned have proved challenging, both at the printer. Philip is also in trying to include items which are of slightly more recent content, and therefore has perhaps held things back a little bit. And this month in particular, we've had a situation whereby the PDFs going to the printers went slightly later, and they were particularly busy at that point, which Philip was unaware of, and so it had a knock-on effect. And then, to cap it all, Royal Mail seemed to have put an extra delay in on top of it. So apologies if you were late receiving your paper journal, but it is not through any desire from us to phase that out at all. Slightly dodgy image, I'm afraid, but the latest issue of the handbook should also have arrived with your journal this month. I'd like to thank Steve Harvey and the computing section director and his team for all their work in putting this together. And for digital members, if you do want a paper copy of this, you can order one online from the shop. Or you could print one, the page you want to off the website. I'm sure that could be manageable. Meetings, once again, thanks to Meeting Secretary Hazel Collette for her work in moving our scheduled meetings from online to virtual. We seem to be very good in astronomy that sort of we set up events. I know I've lost count of the number of events that I've set up, Messier marathons or things, only to then have to go ahead and cancel them all again when the sort of is inclement weather. So, but all thanks to her for her work in liaising with the IOP in respect to this meeting. And we've also got a sort of question mark because we've just been told this week that the IOP is going to have to close for some remedial work, which means that we're going to have to relocate the meeting for December and probably January as well. So we've hot off the press at the moment. The intention is that we will be having our December meeting, which is, I believe, on the Saturday, the 4th of December. A big it's going to be in the Royal Society of Medicine. So we're hiring their auditorium, which is 300-seater auditorium, so which we are going to, yes, we haven't spent money, so in Jeff's thing, we're trying to spend some money, we will be paying for that and not charging people, and even non-members, we will be looking to do it as an outreach event. So that's the next one coming up. The other meetings switched, all the other ones went to webinars, including the Winchester weekend, and thank you to Anne Davis for making the arrangements to switch that over onto the webinar, and also the George Alcock Memorial Lecture, which was this year was given by Jonathan Shanklin, who had the honour of having a glacier in Antarctica named after him, for his work on the ozone layer. The webinars. This has been a positive, and Council this morning, we made a decision that the comment was made that we have had an awful lot of webinars that have been from our members rather than professional speakers, and that's something that we think is a positive as far as we're concerned, and it's something that we want to continue. So the plan is that we've got webinars on the website up until December. We will continue to do them and vary the items. I know the radio astronomy group seem to be making a takeover to do all the webinars, but we actually hope to be able to get a few of the other ones in as well. But we've had the sections have also on the webinars we've had a range of topics. How to image the sun in 3 wavelengths, binocular observing, sketching deep sky objects. This was one of the next one was one of the radio astronomy groups, the HARP antenna, and we've also the last one, which was particularly good in March. We must have had some premonition because we had a talk in March on the daylight fireball. No, it wasn't in March. Sorry, the daylight fireball was in March, but only in January this year we'd had an in-depth webinar about the UK recovering the next meteor sample, which happened to be on sort of in January, and within 2 months we had it delivered. I can't say more than that. I think so. We must be working in some way. So I hope you've enjoyed them. It gives people the opportunity to watch them at different times zone. You can watch it on your TV. And a huge thank you to the people who have actually contributed and helped organise those sessions. The sections as well, so they've taken advantage of it. We've had the historical section, solar section, deep sky section, and radio astronomy section, all doing section meetings, which is really good. So that's taking advantage of that. And there again, this is all about a little bit of thanks to everybody, because without the sections are one of our main factors or main assets to the association. We've got hugely experienced section directors who put in a lot of time. We've got the newsletters, the solar one, the lunar one, that they all basically contribute, and we don't really make enough of a sort of fuss about it, because it's a huge amount of extra items that we provide to members, and really it's something we ought to be banging the drum about far more than we actually do. Bill Leatherbow also stood down as the Lunar Section Director, that he's had that role since 2009. He continued it shortly after when he became President. And he's led the section with enthusiasm. That's 12 years. And many of you will have enjoyed receiving the Lunar Section Circular, which he edited. Tony Cook has agreed to stand in as Acting Director. He's going to be assisted by Tim Hames, and Barry Fitzgerald has taken on the editorship of the monthly newsletter, because I think Tony is still working at, I think it's Aberystwyth University, and so he felt that doing the newsletter as well as running the section would be too much, so he's passed it over to Barry. So the awards. The association's awards is where we recognise members and in some cases non-members who have both contributed to the association and also to the wider astronomy community. The Walter Goodacre Award is the premier award, I would say, in recognition of the recipient's contribution to the progress of astronomy over many years, with special regard being had for his or her work communicated to the association. So this year it went to Lynn Smith, Solar Section Director, for her role as a distinguished solar observer. That she's been in her post even longer than Bill, that's since 2006. And one of the great things as far as Lynn is concerned is the amount of work that she does in analysing people's results and observations when they come in, and as part of that, submitting items to the journal. And as at June, she would either in her sole name or as co-author that she has contributed over, I think it's 112 articles at that stage, and I think the count is still going up. And this is in addition to running the Solar Section newsletter as well, which will pop through many of your, or into your email boxes of every month. So, why have we gone on? In twice. Stevenson Memorial one. Okay, so this shall be awarded to a member who has made an outstanding contribution to observational astronomy, and this year it went to Dale Holt. Dale is a long-standing member of the Deep Sky section and has particular interest in under-observed galaxies, noticeably those in the ARP catalogue and the Higson's group. However, rather than taking images of them, he uses a projection method on his, I think, half-metre telescope, and he then draws the resultant items. And his drawings have often featured in the Deep Sky newsletter, the journal, and also in Sky and Telescope as well. And I've included one on the... Oh, sorry, I forgot to bring that forward. There you are, sorry, apologies. I included this one for his sketch of ARP 19 NGC 145, which has been done just recently. So the Merlin Medal, that went to, so it's in recognition of a notable contribution to the advancement of astronomy, and in this case it went to two in their case, Lunar Observers. And that was Raffaello Lina and Barry Fitzgerald. Barry and Raf are active observers. Raf is over in Italy, and they contribute regularly to the Lunar Section. And whilst they're potentially candidates in their own right, they were nominated together for their collaborative work that they have undertaken together. Their use of spacecraft imagery in conjunction with a professional database is being used by the section to complement telescopic observation. So this is resulting in highly sophisticated geological information, and this is one of their pictures of Grimaldi, Gassendi B, which was taken in June this year, and he's also showing the Plagio class surrounding the crater itself. So Ridley Grant, this is one which in actual fact we've just updated the requirements for Ridley Grant. Ridley Grant is a a grant that members may apply for, that if you are looking at a particular astronomical project, and we've now if people are going to present at a professional conference, they can also apply for that towards travelling expenses. But it enables people to apply for a grant if they were unable to raise the funds themselves. And in this case, it was Monty Leventhal over in Australia. Monty is a BAA member and active solar observer, sending Lynn regular contributions for the newsletter. And he also voluntarily assists down at with outreach at the Sydney Observatory in Australia. I suppose somebody's got to do it, haven't they? No, so he requested the grant. His retirement has meant that his funds were slightly on the short side, and he needed to replace his Daystar solar filter, which unfortunately was not working as efficiently as it should do, and obviously, therefore, for outreach had a safety connotation as well. This is a little bit past news. The Patrick Moore Prize last year was Rita Whiting for Crayford, and her work with both Crayford and the BAA has been tireless up at Astrofest and various other sort of events as well. So we have actually confirmed today the winners for 2021, which will be announced once the nominees have been advised, and the hope is that we will be able to present those at the Christmas meeting in the 4th of December. So next one, this is the website. This is the website, but not as you've seen it before, Spock. This is the website, which is, I've been told not to put it on too long on the screen for too long by Callum. This is a screenshot of the new website that is hopefully going to go live at some point in December is our wish. The website is our main showcase to the world, and the board decided that we would commission a new site that would both look better and also be easier to navigate, and also a key thing for the section directors to be able to update. And we've moved away from Drupal onto something else, to WordPress. Thank you, Nick. So it's the final testing phase, and we hope to, as we said, have it going live soon. We have also, as part of the team we've got working for us on a consultancy or basis, we have Emily Beck, who has joined us. Aid Ashford joined, but unfortunately wasn't able to continue. So we re-advertised for the role using the shortlist, and Emily has now taken up position and been in place around about 6 months, and has been very good in helping us with the website as well. And she is helping the section directors both with content and editing, and also uploading as well. So a new person to the team. I want to raise a thing about the members pages. This is part of our online community. We've got the members pages. We've got the forum, and also sort of we've got the actual pages themselves. So this gives details of the members, and we have the pictures they actually put up. It really is a showcase. If I'm asked, quite often I get asked for an image that we can use for the BAA. I scroll through the recent ones for this, and we've got here, this was just a screenshot that I decided to take. So we've got a couple of, you'll be pleased, Nick, we've got a couple of comets in there, so that's a good choice, wasn't it? We've been spoiled for choice with comets this year. So we've got a picture of Neptune, we've got a deep sky one, and we've got a solar one. So we've really got a reflection on sort of really all the main ones. I would say that, yes, we'd love to have more people on with their own individual pages and posting their pictures. Be great. And really, the final slide is Commission for Dark Sky. That I think it's outside the BAA, and I think possibly even within the BAA as well. There seems to be a lack of knowledge that the CFDS is in actual fact part of the BAA, and I think that's something we ought to shout about again much more. They've introduced this Hidden Stars. It's an excellent new publication that they've brought out. They work with the lighting industry because it's important that we work with the lighting industry. We're not trying to, it's appropriate lighting that is necessary and in the right format. And we're not trying to turn off everybody's lights, which is what sometimes people think. But I'm particularly pleased with this, the BAA proud to support Dark Skies for Everyone. And there is a Dark Sky event in Marlborough next weekend, of which we've taken an advert, and that's the theme that we're doing. It's not just for BAA members, it's for everybody to look up at the sky and enjoy it. So, thank you for listening, and that's the end of the review for our year. It overrun slightly, but I think we've got a little bit more time. Straight into the President's address. Gosh. Move this forward.
Simon, could you just put the lights down?
Oh, you might be able to see it a bit better. Okay, so the Perseid Meteor Shower each August is often an occasion for astronomical societies to meet up, potentially armed with a comfy chair, a pen and paper to record the meteors that they see. I always remember Neil Bone, the Meteor Section director, saying that all he needed was a sophisticated instrument was his trusty deck chair. My thanks for this image that not an image, but this time-lapse of this year's peak from the 12th to 13th of August. And this year was a particularly favourable peak, as there was minimal lunar interference, and it was also clear, although you will see, if we left it long enough, the clouds do come across, but it was remarkably clear. So as you relax in your chair, waiting with anticipation for the next meteor or fireball, you will, of course, see other objects, and that will include many man-made satellites as well. So, my final task as president is my presidential address. And whilst most presidents will draw on their own experience within astronomy and their own particular interests, and you have, if I may, David Boyd with his variable stars and spectroscopy, Bill Leatherbarrow with lunar, Jeremy Cheers with variable stars, Callum with his deep sky, and Hazel McGee with their journal as well. So without having a sort of specifics of interest, as I'm more a generalist and like to go into warmer places to do my astronomy, I thought that I would try and find something which was a little bit more pertinent. And for this, because I've got a personal involvement with a PROAM project, I thought it was worthwhile looking at the observation of artificial satellites and space probes. So that's my talk. So 1957 was a very special year. Now, I'm afraid to have to say that it's with a degree of bias because it was the year I was born, so it was a little bit of a bias on that one. So when you come to, for the year you can born, or the day you were born, you can look online and you can get a picture of the news or a copy of the newspaper for that particular day. And sometimes you also go back and you Google what happened in that particular year, which is what I did for this, to see what else happened, because I knew one thing which happened in October, which was the whole point of this. But there's sometimes things come up, which is a trivia fact that I learned that what happened in 1957, which I never knew anything about, and that was the Toddler's Truce. Sorry, Toddler's Truce. Yes, that the Toddler's Truce was abolished in the 16th of February 1957. And effectively, apparently, up until that point, every evening at 6 o'clock until 7 o'clock, all the television programmes were stopped to allow the children to go to bed. I've never heard of that before, but I was just a bit bizarre. You'd have a riot nowadays, wouldn't you? So that's how you bribe them to get them to go to bed. Or you can watch for another 10 minutes. So that's going back to the special year. This was the year when Sputnik was launched. It was in actual fact part of the international geophysical year, and as part of that, President Eisenhower had announced that the USA would be launching a science satellite into space. And while there may be underlying tones that they also wanted to launch military ones as well, it was seen as being less controversial than the military one initially. It was ironic, therefore, that on the first ones to launch were in actual fact the Soviets on the 4th of October in 1957, less than a month after my birthday. So we have 64 years ago, a very different world. The first artificial satellite hurtled into orbit, and the time was the Cold War era, and the impressive technological skill in actually sending the satellite up to some degree caused consternation in the West. And yet, in hindsight, it actually solved some of the problems, because by the USSR launching the satellite, it did actually mean that the space race had begun, but it also introduced the concept that of freedom of space, where satellites crossed international borders without protest. So after a slow start punctured by many dramatic failures, the technology began to improve at an ever-increasing pace. First, we had the low Earth orbit satellites, such as Telstar-1, which transmitted scenes from New York to Europe, whilst others supported remote sensing and science. Okay, so I'm not sure whether anybody in the room wants to start humming, but Telstar, it was exciting times for youngsters at that time with Telstar, and they even had a name, a song named after it, and that is the Telstar, and that is the 45 was issued at the time by the Tornadoes. So. Somebody's humming it. Okay, rapidly followed by the deployment of satellites into higher orbits, an orbital domain which is now, or was later occupied by the GPS, the Global Positioning Satellites, and more recently by the European, Russian and Chinese variants. And after 7 years, there were satellites which were launched into orbit so high that they appeared to nearly to be unmoving geostationary, which hang above the equator, and which are now obviously used for weather satellites and provide satellite platforms that supported a global network of ground stations as well. So what is the impact on amateur astronomy? So this is Grant Privet assisted me in putting together this talk, primarily because his role, he works down at the DSTL, which I'll explain later. And this is a picture, obviously, of an image that he took. So for the humble ground-based astronomer, that there are hundreds of satellites that are going round over our heads, closer to us than Penzance is from Leeds. And for most of the time, they go uncommented upon and even unseen, because they lie within the Earth's shadow, making them very difficult to see. But those that are illuminated cause problems that, as anyone will know if they've imaged or taken images for anything longer than a short duration. And this was one that the Grant had actually sort of provided me with. So what goes up must come down. Well, not necessarily. So this is looking at orbital velocity, and if I may say, equation alert. Yes, so this is basically the equation that we've got as to the speed that a satellite has to move at in order to remain in the same orbit. Relatively simple. We've got square root of g, which is the Newtonian gravitational constant. We've got the mass of the Earth, and we've got little r of the underneath the line, which is both the radius of the Earth and also the altitude of the satellite above it. So that effectively leads us relatively easily onto to the concept that if you put an object out into orbit, the lower the orbit, once you've actually got it into orbit, the lower the orbit, the velocity has to be higher, and it diminishes the higher you put it up further up into the atmosphere. So this is an additional aspect that looking at orbital lifetimes. So the items, I don't know whether I can use. So we have on the screen, if a satellite was put into an orbit at around just under 450 kilometers, the yellow is in period of high solar flux, and the ones this on the right-hand side are at low solar flux. And effectively, what happens with the solar effect on the Earth's upper atmosphere is there is a large region of gas called the thermosphere, and there is a rise of extreme ultraviolet photons deposited in the upper atmosphere, and that causes a drag on the satellites. So this means that a satellite in the 450 kilometers to start with at high solar flux is going to last probably only about a year. If you bring it out to of low solar flux, then it is going to be in the region of 10 years. So that makes a huge difference to the calculations. So what can we still see up there? What I've tried to do for this talk is look historically, sort of some fun items, the project, and then sort of bring it up to date as well. So that's the concept. So what can we still see up there? So the BAA used to have an artificial satellite section. This was run for 37 years by Howard Miles, starting in 1960, which supported generation and maintenance of orbits for satellites, noting with stopwatches the time at which satellites pass between star pairs. Now, these observations gradually lost their importance as photographic systems such as the Baker-Nunn system and the Hewitt camera appeared and superseded visual observations. These days, accomplishing the same result as the £2.5 million Hewitt telescope is rather easier than using log tables and the processing the emulsions for your sort of tri-X or whatever emulsions that you use for your film. So observing satellites for fun, that the main one on here, I would like to, this is a picture which is really impressive, I would say. This is taken by Chris Hooker of the Newbury Astronomical Society. Back from July last year, there was a particularly good pass with good seeing of the International Space Station. Chris uses a special setup to be able to do this. When you've, I don't know whether those of you have tried taking pictures, that it's a case of having your video camera sort of running and trying to slew along the path. He's taken it to a little bit more of an advanced level. He's got an old EQ5 mount, which he's stripped down and mounts in such a way that the polar axis is parallel to the direction of the pass. The declination axis then provides the west to east movement, and north-south is done using the polar axis. So this is using his Newtonian telescope, a 5 times power mate Zoo Optics one with an eye-off rejection filter. So it's a stack of around 6 milliseconds each, but on there you've got the Dragon capsule, which is here, half illuminated, and part of it's shielded by one of the booms. You've also got the Progress Progress 75 supply module. It's dot to the trailing end, which is down here. We've also got the multi-pronged shape in the middle left is the space exposure facility up here, and the robotic arm, which I believe is down, I think this one here as well. So it's just incredible, the fact that it's how quickly it goes over, and what a good picture that he's actually got on that. Historical items that you can see as well. So this one was this was Vanguard 1. So this was looking at one that is post Sputnik. Sputnik 1 decayed after only the orbit decayed after only 3 months. And every subsequent Russian satellite that has been launched up until Electron 1 in 1964 has burned up. So the oldest Soviet satellites are gone. But this tiny Vanguard satellite, launched in 1958, still remains in a highly elliptical orbit, but it can be seen if you know where to look. This was also another one. This was Prospero, which was launched in 1971, and I'm used this picture because it's the only UK satellite launched using a UK designed and built launcher, and it's 50 years old. In actual fact, October this month, and its launch was a major technical achievement for a project that had already been cancelled at the time. And I used to work very close to the RAE in Farnborough, and it was a major sort of effect that it had, that the British lost the ability to participate in the launch market because we gave up that launch facility. It's a great shame. This Prospero continued broadcast until 1997, but events or attempts to turn it back on again floundered because the RAE was privatised and is kinetic now, and a lot of the previous documents were discarded. So you can actually see it. It's about a 6 magnitude if you know where to look, and so you can get it with a tripod-mounted camera or even binoculars. So how far away can we see that a man-made object? This is something we're often asked with sort of outreach events. So if you get your timing right, you can see geostationary satellites as they sometimes catch the illumination of the sun. You can, of course, they get up to 6 or 7, and you've also got iridian flares, which you can pick up on heavens above, which are spectacular, and you can sort of get them down to even 0 magnitude. So it's an exciting time for outreach events to look those up. Now, this is, Nick will look in consternation at this one, because, okay, so this is I put in the Apollo fuel dump. So this back in 1969, there were observations made by BAA members, and maybe it'll become pertinent again with Russia, China, and who knows what's heading off back to the moon. This, I believe, is an image by Michael Hendry back from 1969. Which was a dump, and but I just included this one in there. I've left it as fuel dump rather than propellant dump, so much to Nick's annoyance. But I've wanted to actually bring it up to date by contrast to the next slide, which I'll cover in a minute. They're showing the difference between I believe this is either between, I haven't got the details exactly, but it's between a 3 and 5 minute exposure. And there's a note on the forum just recently that had, there was an article in Sky and Telescope which referenced the BAA meeting in December 1969, where Commander Hatfield gave a description of his taking the pictures of the fuel dump going onto the moon. And again, on the Apollo 12, that more than 32 years later, Peter Birtwistle managed to get an image of the 3rd stage of the Saturn V launch that was made. Once again, that was 32 years ago. Oh, sorry, that was 32 years later, back in 2002, but it won't be back until 2032 for the next time. So how far away No, we've got another one. So this is the propellant dump, and it's propellant because it's got the fuel and it's got oxidant as well. So therefore, it's a combination of two, which is the propellant. So this is a video. This is a single grab from the video, which is a really good one. This was from I think earlier this year. That I believe in May this year, and it basically is a sort of a dump, but it just shows the difference in the quality that we are able to get and what people can do. And talking more of that, this is possibly, unless other people know differently, this is a picture taken by the DSTL that the Tesla Roadster, which is somewhere between Earth and Mars orbiting. This is an image. It's generally about 27th magnitude, but occasionally reaches 23rd magnitude, according to JPL Horizon's website. So quite what the paint job is going to look like when it sort of comes back around next time, but sort of the suggestion is perhaps you should look with it with a sort of using red filters if it's sort of done the job accordingly. So tracking objects in space. This is apologies for the initial slide quality. This is my personal involvement that we had with the DSTL, which is a Defence Science and Technology Laboratory, and they're based down at Porton Down in near Salisbury. Since this time when I was doing this, they've also had a little bit to do with Novichok as well, but they were more in the news. But they are part of the Space Situation Awareness Project. And the reason that I took this, I was the secretary of the Basingstoke Astronomical Society near Salisbury, and so I asked them to come and give us a talk. And during that talk, they were sort of saying that we were saying, oh, we get loads of images which are spoilt by satellites, and they said, oh, we'd be really interested in those because we want to see whether we can use those images to track ephemerae, and so that's how a project was born. On there, you will also see that there is the IADC, which includes the UK Space Agency, and it works to try and what they're hoping to do is to get wings fitted to satellites so that when a satellite becomes end of use, it can basically have its wings extended, and it will then increase its drag and come back down to Earth very much quicker. So that's what they're working on. And this is what led to a citizen science project that I was involved with called the Argus Citizen Science Project, and whereby we tracked the Removed Debris Satellite. Removed Debris Satellite was a mission by the Surrey Satellite, the University of Surrey Satellite team, or small Surrey Satellites, I think they're called now. It's the size of a domestic fridge, about 400 kilometres in altitude, and it basically showed that we were able, with either uncooled CCD cameras, DSLRs, or just with a inexpensive camera lens, that was all required to redefine a satellite's orbit. The big issue that we had, which needs to be addressed, and I know that members of the BAA will have already come across this, of close approach objects to the Earth. The timing is essential, and I was using it initially a thing called Backyard EOS, which gives timing to 1/1000th of a second. The only trouble is that the error bars are at least 2 seconds on there, and so therefore it was completely useless as far as that. So we needed to use GPS dongles and software to make our observations worthwhile. So this is really a sort of slide on the fact that space is crowded, and when I received this, and I had a word, I was talking to Nick, and I said, what on earth happened then? And because that's everything sort of looks sort of fairly sort of normal until that point. And so we've got two events then. We've got the first one, which is in 2007, I believe. It's the Chinese, where they deliberately took out one of their own satellites there was a military test mission, so they took that one out. And then there was also a subsequent one, which I'll talk about a little bit later. So by and large, space going into space does leave a lot of debris there, but it's the unintended items which cause as much difficulty, and the speed that they're travelling does cause damage both to ISS and others. This is a track that I took sort of, just the other day for the items of what is tracked and what isn't. So this is giving an indication. This is a commercial company that enable people to subscribe to it. So I've rotated the Earth round to give the North of America and Europe, but it is a crowded place up there. So as far as the summary, this was for the Argos project. Results have been presented both at the NAM conference in Lancaster a few years ago, and they've been in various publications as well. But in essence, what we were able to do was to show that it doesn't actually necessary to use hugely sophisticated. It can using certain algorithms that you can get confirmation of ephemerae. We were able to track removed debris, and you may be aware removed debris had two elements to it. It was catching a satellite, so it's threw a dummy satellite out and then used a harpoon to catch it, which they said to NASA that's what they wanted to do, that NASA's flights have almost fell off their chair, so I understand. But it finally got approved and it worked. And they also deployed a net which also caught the satellite. So what they were trying to do was to demonstrate the feasibility of catching a satellite to bring it down out of orbit at a quicker rate. So we were able to do that. And that was, I've already talked about that. So many low Earth objects are visible with minimal equipment. Now, so what are the future? This is, I've jumped a couple of slides. What have we got? Missing a slide. Okay, so what's the future? Are they moving across yet, Nick?
They're coming.
Yep.
Okay, right. Okay, so this is my latter part of the talk. You'll be glad to know. So SpaceX, the space technology company founded in 2002 by Elon Musk, had made no secret of its plans. And the firm began talking in 2015 about putting a constellation of satellites into low Earth orbit, and launched the first of the two Starlink satellites on the 22nd of February 2018. However, it was only really the orbit of the first 60 satellites in May 2019 that caught astronomers by surprise. And really, they weren't prepared for it. And when they really saw the effects of the streaks from the satellites on the astronomical images, it became clear. Are they still going across? Yeah, they are. They're still going across. Anyway, all 60. I took the soundtrack off there because Nick was going, bloody hell. So whilst some people refer to them as light pollution, we do need to be cautious using this sort of phrase, because back in sort of lockdown, or just post-lockdown last year, we had a Facebook group for our local neighbourhood, and I started an astronomy version, and I took people out to see this, and they were going, "Oh, that's wonderful." Beauty is in the eye of the beholder, as it were. So this is effectively, basically, this only goes back. This is the cost of delivering, items into low Earth orbit. It's dropped considerably since 1981, and obviously 1981 with the reusable shuttle was a huge reduction on the single-use Saturn V and such like. So it's come down. The shuttle initially, that got progressively more efficient. We got the Falcon 1, the Atlas, Falcon 9, and then the latest offering from SpaceX being the Falcon Heavy. Now, NASA's goal is in 2040 is to be having it down to the tens of dollars per kilo, but whether that is going to happen, who knows? And the item on the space elevator, yes, the technology hasn't really been launched yet anyway, so we shall see. So this has had a huge effect on astronomy in general. As I said, that people didn't really wake up to it until such time as the first launch. And back in 2020, in August, there was a conference convened. So let's move forward. It was called SATCOM-1. And basically, this is from the report that was issued, this is from an observatory over in the States. And more or less, you can spot the occasional one which hadn't been sort of hit by a satellite or two, or at least one satellite moving across it. So it's having a huge effect, or potentially having a huge effect. And so at SATCOM, there was 10 key recommendations. They were split between the observatories and the constellation operators, i.e. SpaceX, but there's not just them, there are many others as well. And the others, the third lot of recommendations were for these two in conjunction. So since then, we've now had SATCOM-2. These are slides that are taken from, this was held virtually. There was a Deep Sky Symposium, which was supposed to be held face-to-face in La Palma, and for some reason it got cancelled. I'm not quite sure, but that was in end of September. So that was held, and also the SATCOM-2 version. So looking at the 10 recommendations, the SATCOM-1 concluded that there were never going to be full, they couldn't fully avoid all impacts that were going to happen on this. So we're looking at the SATCOM-2 was the working groups addressing how best to implement 3 of the SATCOM-1's recommendations. So the working group for the implement SATCOM-1's 8 to 10. 8 to 10, number 8 is coordinating observation of satellite and constellations. So that is where I see the BAA being involved. At the moment, we're in discussion with the RAS, the BAA, the SPA, the Federation of Astronomical Societies as well, to try and get a project in place that is being coordinated by a guy over in the States, Meredith Rawle, who is going to try and coordinate what is required for the professionals. So it may well be that they will be interested in receiving images that have had items or satellites moving across them. What we're also going to be looking at doing, again, helping back to the Argus project, to be trying to redefine how accurate the ephemerae are that sort of the operators are sort of providing. And they're also looking at the effects on not only visual, but on radio as well, because there is a huge concern that whilst at the moment that there is some protection in the radio waves area that astronomers use, that may well be diminished and they could be affected as well. We've had some luck that the graph on the left was the initial one, with a magnitude of V of around mean of around 5. Scientists after SATCOM-1 talked to SpaceX. SpaceX have made certain adjustments. Some of them have worked, some have not, but they've realistically taken the mean down to about 7th magnitude. So it may well, as some people have said, it'll be great to be able to have a magnitude 5 visibility at home because of light pollution. But with the naked eye, it may well be that you won't see these satellites. But certainly, as soon as you pick up a pair of binoculars or start taking an image, then you are going to see them. And it may well be with the growth in the number, it may well be that sort of every time you look up a pair of binoculars, you will see a satellite coming through. So this is SpaceX's Starlink. It just gives you an indication. This is the ability they have of rolling, shading, and even potentially putting the visors on. Lots of you will be aware, but initially what happens is SpaceX deploy into a lower Earth orbit. They run tests on the satellites initially to make sure they're actually working. If they don't, then they can decommission them and bring them back down again. If they do work, then they're elevated to a higher working orbit. But the point at which that is done, and so that the solar panels can be folded up in the lower Earth orbit, but when they're actually being used in higher Earth orbit, then they are required. So there's nothing that can be done about that. This is a distribution of the Starlink satellites at the present time. There is a polar gap at the moment, which unfortunately will be filled. So this is just one company basically. So if you add onto it, you add on all the other people, Russia and China and so on, and all the other people who want to be putting up satellites, then clearly the issue is not going to get better. So what of amateur astronomers? This is again from Nick. Thank you very much indeed. Again, Nick. We are about the worst place at the moment. We are about 52 degrees, which is when in the orbit it tends to come to 52 degrees and then go south again. So for imagers, there are increasing options there have been recent articles whereby the trails can be removed electronically, and with CMOS cameras predominantly taking shorter exposures, which are then added together, this can be quite effective. So this is one thing, but the SATCOM conference was looking at, it started off being a SAT fix program, and it ended up being, they said, SAT mask was a more appropriate word because they can't fix them, but what they can do is they can help to remove the items out of your particular image. Now that's fine for images. I would have to say though that if Ron Arbour had are you going to digitally cover up his supernova that he's been waiting to discover for years and years, or a new nova, that clearly for people who are trying to find something which wasn't there before, it is going to have a pronounced effect on that. So this is where we're looking at the SAT Hub of coordinated focus, enabling astronomers, community members to work together. The primary goal is to inform timely low Earth object observing. The secondary one is to look at the software algorithms and to look at alternative ways so that the satellite companies will provide us with more details, and that they have asked for them to be provided every 8 hours or when a manoeuvre has been made. And also they're looking at enhanced, at the moment we have TLEs, two-line elements. We're looking at perhaps a more sophisticated means of actually finding them. And also there is looking at the basis of there may well be some contribution, because effectively these companies are using our space for their benefit, and really that they shouldn't just be trampling over everybody else's view of the sky. That's my opinion anyway. So how do we actually do that? I've talked before, this is Nick James provided this one as far as video camera. You've shown today, I've seen today how effective it can be. You've got individual timings on the items, which makes it very much easier, provided you've got the time right in the first place, to be able to say that was a particular satellite and that was its position at, and have several readings for each satellite. So really to conclude, so astronomers and space agencies have used the same space for 64 years, and up until now the collisions have been rare, but we've just ISS and Hubble would have to be moved on a regular basis, and you remember on the slide with the increase of the space debris, that there was a Chinese satellite that exploded. Shortly afterwards, there was an Iridian satellite that crashed into a sort of a no longer used Russian military one, which contributed another over 2,000 pieces of space debris as well. So if we get it wrong and we don't have that, then it gets very quickly the amount of items that are in there, and this could have the effect of making. In one direction, we've got the low Earth orbit costs are diminishing substantially, but if it gets too crowded, we won't really be able to use it at all. And this is going to have a profound effect on astronomers and really the wider humanity, that as far as it's not really been quantified. So international sky is predominantly unregulated, so we're trying to work on that. And realistically, the one sort of the SpaceX have said that the objective is to bring affordable communication to lots of people in the world. But then they're wanting to charge, I think, $80 a month or something. So how affordable is for that for the people who haven't got there at the moment? So we will have to wait and see on that score, I'm afraid. So the end, and some credits at the end. So that's my address. So I'm free to answer questions, or we have like 10 minutes before tea to cover the. We have got the election results, but just a few questions if anybody wants to, or we're quite happy to move on to the election results if everybody so wishes.
Thank you very much. Got a question.
Have you got a question? Oh,
It's just a point, really.
Okay.
Can you hear me all right? I'll
So-
speak a bit louder
so-
anyway. Where's my microphone or something?
John, I'll just read your question out if you say it, and I'll read it out so the guys on the live stream can hear it. So.
Okay. Just about, you mentioned the Hewitt cameras, or some Hewitt cameras, that they were used to take a lot of photos by the RSRE of satellites and so on. I'm just going to add that the photographs still exist. You're probably aware that they actually belong to the BAA, and they're situated at Creighton Manor House at the moment. I'm not going to say any more about it, but they do exist. There's 10,000 of them, but they may at some time have to be moved. That's to be discussed.
we're getting quizzical looks from our archivist mind. Okay, so it was more of a comment than a question.
So Alan, do you just want to say what the comment is?
Oh yeah, okay, sorry, okay. So the comment was that there are a lot of the images that were taken by the Hewitt camera, which I mentioned down at Farnborough, which was developed at a cost of £2.5 million, so I understand. A lot of them are still in existence and are currently stored down at Crayford with the Astronomy Society there. So it may well be that if you're looking to move them, then our archivists may be interested in at least. Oh, okay. Oh, okay, right. Move on quickly then. Okay, so if I may, bright light. That's a satellite's just gone through the field of view. So if I can ask Bill Tarver, the BAA Business Secretary, to come up to the lectern and give the ballot results, if I may, please.
Thank you, Alan. Right.
I've got the thing here.
Oh, you're going to work it for me? There we are. Good. Okay. Total votes cast, we had 429 digital, 114 paper, a total of 543, of which 5 were void, 5 were blank, giving 533 valid votes. Next one. So, officers, President David Arditti, 490, Treasurer Jeff King, 476, Secretary Bill Tarver, 468, Secretary of Papers Jeremy Shears, 479, and Secretary of Meetings Hazel Collett, 465. Ballot for trustees, John Shooter, 359, Anne Davis, 403, Janice McLean, 394, Richard McKim, 395, and Lynn Smith, 365, and they were all elected as trustees. Tim Parsons' votes of 161 were carried over the election for the ballot, for the election for council. And on council, 3 candidates: Mary-Louise Archer, 406, Alexandra Hart, 408, and Tim Parsons, 423. So my thanks to the scrutineers of the ballot, Maddie Davey, Julia Palmer, and Jane Rickard, and thanks to Andy Wilson for organising and managing the online ballot, and the results will be posted on the website. Thank you.
Thank you very much indeed, Bill, for that. And that is going to bring to an end the initial session of the AGM. We will... Oh, sorry.
I could ask a question as well, just about the accounts.
Right, okay, yes.
Is that all?
Okay, go ahead.
So we had a very good, I was going to ask a question earlier about the
Okay, can I just ask you, Nick, can we just take a microphone over?
Bring the microphone.
Right, just for those of you who are watching on YouTube, we are breaking for tea at 4 o'clock. At that point, David Arditti, having been elected the president for the next 2 years, will take up the duties at the lectern. So I will sign off. But just before that, we have had somebody within the audience here who would like to ask a question about the accounts. And so as we've got 5 minutes before tea, what we're going to do is to get a microphone to the person and also bring Jeff back on screen to give an answer. Hopefully not. You don't need to go back to all the...
No.
Okay.
I hope not.
No,
I don't know.
it was about the deficit, which was something I was going to raise anyway, because it was a concern to me when I looked through the accounts again. And I think you were talking about an 80,000 deficit. We've got 35,000 being covered through the closure of the office. But maybe I missed it, but I didn't hear anything about the remaining of 50,000. What are we going to do about other reduction in that deficit?
Okay, this is the same question we had last year. And it depends on which part of the expenditure you look at. But in my opinion, we should be running a deficit of probably about 100,000. We have reserves which, in my opinion, for a charity are far, far too high. We should be spending money on members and public benefit. So I don't think, if it was all totally up to me, that I would be looking for a zero deficit. Now, we can argue one way or another, but I don't think we should be in the business of just accumulating cash, which is what we have been doing, because our investments, I don't know if you know this, but one of them went up by 22.5% last year. And right now, it's already gone up another 9% this year. So our operational deficit, yes, that is going to be probably more than 50 grand, because we're going to spend some of that money on moving things out of Burlington House and so on. But I would not be looking for a zero deficit. Now, you know, we could argue, or we could rearrange the way we talk about the accounts and say, okay, we've spent 60,000, or, well, actually it's a lot more than that, on public benefit. But it's just how you count the numbers, really. I don't know if that may not...
Yes, I think that's it. I mean, maybe we should look at the accounts differently, because then we could put the things that are one-off spending for public benefit on one side, and the other off, which is actually keeping the lights on the other side. Now, if there's a balance on keeping the lights on, that would be acceptable, and then any donations, legacies, profits from investments could be used for investing in the future.
Yeah, I completely agree. Yeah.
Thank you.
Well, I was just going to say that we continue to keep the expenditure under review, and yes, if we can make savings and streamline systems, then we will do that. This has been a huge step in the right direction, I believe, to look at Billington House. We've talked about it for a number of years, and we've actually come to do something about it now. So let's celebrate that, because and we will then keep an eye on it. But we do, and I would ask members in general, if there is something that you think the BAA ought to be doing, then please contact us. Please say that, or wouldn't it be a good idea to be doing this or that? We've got this money, and we have to be utilising it both for our members, but also for the greater good, because it's part of our charitable status that we promote astronomy with everybody. And if we can get more people to be members and to be more interested in astronomy, and we can diversify and get more younger people involved as well. So that would be great. So if people have, both here in the room and also online, if you've got ideas that why doesn't the BAA do this, then please let us know, and we'll consider it, because we're looking for projects, and we've asked for the RAS to collaborate for pro-am projects. So if you've got an idea for a project and you know of something, then let us know, and we'll try and do that, and we can put some money towards it. Not so we're going to spread the money, so to throw it around, but it's a case of judicial spending and promoting the association is appropriate. So anyway, I think if that's okay, then
Alan, sorry, just before we finish, so Alan is standing down as president, and I think we would all like to say a vote of thanks. This has been a very difficult time to be president, what with the COVID situation. So can we give Alan a round of applause, please, for being with us?
Thank you very much indeed, Paul. Thank you. So if we can pass on, so we'll nip out to tea now. So I'm not sure whether we're supposed to wear our masks, but if you wish to, they'll get a bit soggy. But so, and then when we reconvene at past, it'll be David Arditti in the chair. Thank you very much indeed for watching.
It is now 16:30. So I will now restart this meeting. This is technically a new meeting. We always used to advertise these two meetings that we held at the AGM as separate meetings. One was the AGM, and then we had the ordinary meeting. Well, we're not using the term ordinary meeting anymore, but in a sense, this is a new meeting because we have just finished the 131st session of the BAA's existence, and we are starting now the 132nd session. And I would just also like to repeat my thanks to Alan for the fantastic job he has done in this very difficult period of the last couple of years as president. And I'm very honoured to be asked to step into his shoes, as it were, and thank you very much for supporting me and voting in the recent election, and I hope to do this grand and historic association justice. And one slightly funny thing I've noticed, I've done a little calculation about how many presidents there have been. In general, we've changed presidents every 2 years since 1890, but there was one president who only lasted 1 year. So taking account of that, we have actually had 66 presidents so far. So I will be the 67th president of the BAA, or 67P, which is actually Comet Gerasimov. Churyumov Gerasimenko. Right. So, of which more later. If there are any new members here today attending a BAA meeting for the first time, I'd be delighted to say hello to them. But I don't think there are actually. Yes. We also generally, at this point in the meeting, have you told what papers have been approved by the council in the meeting that they held today. The paper secretary, Jeremy Shears, is not here today, so I will tell you that council approved one paper for publication today, which was the paper on the 2020 opposition or apparition of Mars by Richard McKim. So that will be published in due course. Notices, well, the sequence of webinars, which has been a popular and successful addition, forced on us initially, but we will be keeping them going. The webinars will continue. In November, there's a radio astronomy section Zoom meeting on the 5th of November. There is a talk on the Winchcombe meteorite on the 17th of November. And in December, the radio astronomy section are getting together on December the 3rd. But then we have an actual meeting in person, which I hope you all and many others will be able to come to. And that is the Christmas meeting. And that will be on December the 4th at 1400. And that has already been advertised as occurring here, but it will not be occurring here. Unfortunately, the IOP have had some trouble with the systems in this building, which is quite a major issue, and they are going to have to close this building during December and most of January. And so we were only informed of this about a week ago, and so in a tremendous emergency, we had to go rushing around, and Alan had to go rushing around trying to find an alternative venue for the Christmas meeting on December the 4th. And we have found a venue. It is a very nice venue, a very posh venue. It is the Royal Society of Medicine in Wimpole Street, W1. It's a very expensive venue, so you are worth it, though. And we will not be charging you for it. So it will be, it should be lovely. And we have some very interesting talks, speakers coming from far and wide to regale you on that occasion. So, and notices will go out by email and in the newsletter, the emailed newsletter, giving you the exact details of that, but I'm giving you advance warning now that we've had to make this change. So the meeting on December the 4th will not be here. It will be at the Royal Society of Medicine in Wimpole Street. And then we've got a couple of other online events. Christmas Zoom lecture from the radio astronomy section on 10th of December, and another webinar on exoplanets, the present and future, on December the 16th. So those are the upcoming meetings, and it's all go, really. The next thing that's going to happen now is that we have a talk from our esteemed and very well known to you all, I'm sure, Director of the Mars section, Richard McKim, and he needs no introduction, really, a past president and a fantastic servant of the association over many, many years, and great expert on Mars. And Richard is going to be talking on the subject of new colours for old images. So, Richard.
Thank you very much, Mr. President. Good evening, ladies and gentlemen. I wonder if I could have the lights down, please. Would be great. They say that a picture is worth 1,000 words. So a colour picture must be worth at least 1,001, yes? We hope. I'm going to talk to you a little bit about some of the work that I've done in the past and some work that I'm continuing to do on making colour images from old planetary photographs. And those of you who've been in the association for a few years might have seen the paper referenced At the bottom there, published in the journal in 2013. On the screen here is Earl Slipher. Slipher was appointed by Percival Lowell to the Lowell Observatory staff in around 1905 as a photographer. He's a graduate of Indiana University, and a very skilled man, not only as a visual observer, but also as a photographer. And Slipher took, I think, something like 40,000 or more photographs with this instrument here, which is the 60-centimetre refractor on Mars Hill. And he was able to observe all of the oppositions of Mars from 1907 to 1963, which is quite an impressive period of time. And like most photographers, most of his photographs remained as negatives, or rather photographic plates. They didn't tend to get printed unless there was some particular reason for printing those photographic plates. And when he did print the photographic plates, he tended to print black and white copies. And of course, if we go back to the turn of the 20th century, it was extremely difficult to make colour photographs at the time. There was no direct colour film when he started his programme, and only later did colour film become available. The problem with colour film of that time was that it was extremely grainy, and the results were just not satisfactory. So Slipher was taking old-fashioned photographic plates, and like many amateurs today who take CCD images, was trying to get the moment of the best seeing for his planetary images. Now I'm going to pick up this remote control, and I'm going to press one of the buttons at random and see if it works. Oh, it did. Amazing. Amazing to have picked the right one. Now, in this particular slide, we're looking at the value of compositing. Now, the picture at the top there is a single exposure. It's actually from 1948. You can see that it's Saturn, but you can see it's not a particularly good photograph. It's quite grainy. It's a photograph taken with a yellow filter, which was quite common at the time. You can see some of the detail there. You can hardly see the south equatorial belt above the equator. But what he's done there in the second one is to take 10 images and to add them together. Now, he's added them together not with a computer, but he's added them together in the darkroom, one after the other, lining them up absolutely precisely in a frame, and then developing the resulting copy negative. And you can see that the large clumps of silver have been largely cancelled out by this process. However, if you take images over a long period of time, any fine details, like spots, for example, would be smeared out by the rotation of the planet. So this is quite a good technique. The trouble is, I would imagine that it would take him an entire day in the darkroom to combine 10 images. Now, hands up those of you in the audience who've taken photographs with a webcam of the planets. Let's have a look. Can't just be me. And you typically will take many thousands of images and arrange them together with your computer in a matter of seconds. But to do 10 photographic images would have taken Slipher an enormous amount of time. And you might have noticed that the result is still in black and white. Let's go on. I became interested in this retrospectively. In 1986, I had the great good fortune to be invited to spend 2 weeks with the exclusive use of the 1-metre Cassegrain telescope at the Pic du Midi Observatory with my old friend Jean Dragesco, who passed away recently at the age of 100. And Jean and I were photographing Mars, and he took, with my assistance, some lovely pictures. The top row, in the middle, is a red image. That's a single shot, and it's photographed on TP2415 film, which was the miracle film of its day for being relatively fast, but also having very fine grain. So the CCD revolution was, of course, just around the corner, but hadn't quite happened to amateurs at that time. For the following opposition, 1988, they took away the eyepiece and stuck a CCD camera there permanently. But we were the last of the photographers. And that photograph at the top, the red image, as I was always pleased, it was one of the sharpest images ever taken from the surface of the Earth at the time. The one underneath it is a blue filter, which shows mostly the details of the atmosphere. And many years later, I thought how nice it would be had I had a colour photograph. Well, I had taken some colour slides, but they were very, very grainy. So we combined, with the help of Johan Varel, the red and the blue image to make a synthetic green image shown at the bottom left, and then we put them together to form an RGB image at the top. And that seemed to me quite satisfactory. And then later, when I learned to use Registax and other image treatment software, I thought how nice it would be to fiddle around with them. So on the right-hand side at the top, you've got the red image which has been sharpened in Registax. And we can begin to see some fine details. We can see the Tharsis Montes there, which are hardly shown on the original image. And then, of course, the same with the RGB image on the bottom right. So that's the final result. So I was very pleased with that. And bear in mind, these are averages of just 2 images. I thought how marvellous it would be if I could find a historical archive of black and white photographs that I could average together, where I wasn't dealing with just 1 or 2, but perhaps dozens of images. What sort of results could we get from that? So Johan and I got together and we did this with a series of Lowell Observatory Mars images. These are from the years 1941 and 1954 in these particular pictures here. And on the right-hand side, blue, then yellow or green, and then red, and on the left, the synthetic colour results that we obtained. So very pleased with that. And quite recently, I was doing some old Jupiter reports for John Rogers. The BAA Jupiter section published reports on all the oppositions of Jupiter from 1890 up to 1948, and then there was a bit of a gap. And nobody ever went back and wrote up the missed years. And in retirement, I decided that I would do that myself. So I went back and I've produced some papers. And I thought how nice it would be to get hold of lots of data from other parts of the world to include in these papers. And so that's what I did. Now, Slipher, towards the end of his life, reluctantly published 2 books about his work. He was a really enthusiastic photographer, but he wasn't a really enthusiastic writer. He didn't write enormous numbers of papers. On the bottom there, the bottom line is a sequence of photographs from 1949, one of the oppositions I wrote about. On the left, we've got a green plate. On the middle, we've got a red plate. And on the right, we've got a blue plate. Now, you can see, if you look on the blue image, the right-hand one, you can see that the belt below the planet's equator, the north equatorial belt, is a lot darker in blue light than it is in red. And that's because it's reddish-brown in colour. So it appears to be darkened in blue light. The equator, the equatorial zone, is slightly yellowish, so that appears a bit darker in blue light as well. So you can put these images together using modern techniques, and you get a not very satisfactory colour result. So I thought how nice it would be to ask the Lowell Observatory archivist, Lauren Amundsen, if she would kindly scan the original plates from their collection. So that's what we did. So this is the red or the yellow plate. I've forgotten which, and this is what you get. So Slipher would put the plate in. He would rapidly take a series of images. We've got about 20 images on this plate, and this might take him perhaps 5 minutes. There isn't much rotation of the planet in that time. Now you can see, even perhaps where you're sitting, that there are some defects on this. It's after all a photographic plate which has been stored for half a century. So there are bound to be a few scratches, a few marks where there was a bit of grit in the water used for developing the plate, and so on. So what you do is you select in the computer, you scan it, you improve the contrast, and you pick the best negatives that you can find. And you might need to do a little bit of repair work like scratches and that sort of thing. And what you can then do is you can stack them together. Here's the blue plate, different orientation, different size. The blue film was less sensitive to light in blue wavelengths. And again, we see some problems. We can see there's a place there where 2 images, for example, have overlapped. So we can't use those. And we certainly can't use the one person has drawn some arrows on. I'm not quite sure what they were doing there, whether they're having a game of noughts and crosses there, I'm not quite sure. I think they were trying to point out image defects, or maybe perhaps the best pictures. He occasionally put some arrows around the best pictures. Slipher had a very good technique of saving photographs, by the way. He was pestered all the time by people wanting photographs from the Lowell Observatory. So instead of keeping the best ones in the plate vault, he had a cigar box on his desk and he put the best ones in that. And if anyone wanted his best plates, they'd have to come and ask him personally for them. They couldn't steal them from the plate vault. Now, if we go forward, this is the next stage of the process. So on the left-hand side, I've picked the 3 best yellow frames, and I've averaged them together using the Registax freeware software. I've done the same with red. The red one, R in the middle, I managed to find 6 really good frames, and the blue, I found 8 good frames. And then all it requires to do now is to put them together. And with this work, I acknowledge the cooperation of Emmanuel Cardasis in Athens. And we've got now the earliest colour photograph of Jupiter. This is the earliest one that was ever taken. And Slipher in his lifetime didn't make colour prints of Jupiter. He made a few colour prints of Mars, but that probably would have taken him days in the darkroom to do. And of course, now it takes a few seconds. I should say, of course, that in the time those red, yellow and blue plates were changed, of course, time was moving on. Jupiter was rotating on its axis, and therefore some of the details moved. And those of you who've done a bit of planetary work will know that there's a program called derotation, where you map project the images to a Mercator projection, and then you shift them along a little bit to allow for the rotation of the planet. And then you can wrap them back into a sphere and recreate your synthetic colour image. And so there it is, 1949. The south equatorial belt has just faded, which is normally a sign that there's going to be a strong revival of that activity. And sure enough, that was what happened a few days after this photograph was taken. Here are some other black and white photographs from this time, the yellow and red filter photographs. And I just wanted to point out some of the other features of the apparition. On the top right there, you can see the red spot hiding on the following side. And on the bottom right picture, taken several months later, you can see the red spot is just a white area. This is the red spot hollow. It's been covered by high altitude cloud, and we can see some other spots associated with the south equatorial belt revival. And I also wanted to do a composite with the red spot on the central meridian, and there it is. So there's the earliest known photograph of the red spot from 1949. Now, I was looking at the red spot a few nights ago, and I measured it to be about 14 or 15 degrees long. On this photograph, it's about 30 degrees long. Of course, the red spot was much more colourful in the past, and as they say, things aren't what they used to be, and the red spot is a lovely example of that. It's shrinking, so get out there and see it before it disappears completely. So there it is, and you can see now the image does confirm the brown or reddish colour of the north equatorial belt, and it does show the yellow of the equatorial zone, and indeed many other features. Another feature that long-term planetary observers might notice is the white ovals in the south temperate zone. So if you go just above the red spot and a little bit to the left, you'll see that white lozenge. And in 1949, these ovals had only been observed for less than a decade, and they were really very, very long, and later they condensed to form quite small features that we see today. So a very colourful slide, and something that I was very pleased to do. And of course, having done one, where to stop? So I went on, and this is just to show you that contemporary observers did see these colours. There's a drawing on the left by Rees, the American observer, and on the right by Lebering from the former East Germany, which showed the same colours recorded by Slipher. If we go on to the next year is quite interesting. It was photographed at Mount Palomar. Now, you might find it quite surprising to see photographs of planets wasting the time of a giant telescope. These were taken by Milton Humason, who, of course, is known for his extragalactic work. But at the time, they were still commissioning the 200-inch and trying different photographic plates. So there's some blue and some red exposures. And I thought how interesting it would be to make a colour composite from these. But here, the difference in time is simply too great for any sort of software to make a result. However, Slipher had a remarkable set of good photographs in the late summer and autumn of 1950, and here are some of those photographs. So the top row, yellow, red, and blue light exposures, and on the next rows, the colour composites made from combining those results. And we can see some striking and interesting changes, a few shadow transits of satellites as well. We can see the red spot hollow aspect has persisted. There's a very bright white spot in the south equatorial zone, and the two of the south temperate ovals have come very close together. And there's this rich brown colour of the north equatorial belt, but the planet isn't quite as colourful as it was in the previous year. So I really just wanted to illustrate how interesting it is to go back into the past, into the plate vault of the Lowell Observatory and no doubt many similar institutions, and to make new colour images from old photographs. There's an enormous amount of stuff there waiting to be done. So I'm hoping to go through more of these images and make more colour composites of Jupiter and no doubt Mars as well. And it would be good if other people could do this as well. This, I think, is my favourite photograph. It looks a bit blurred from the front, but it might look a bit better from the back of the room. And this is another 1950 picture of Jupiter, showing the enormous range of colours there, from the bluish plumes in the equatorial zone to the brown, orange-brown of the north equatorial belt. And so it's interesting to go back to see all of these colour contrasts and these details. And of course, these photographs can be measured for detail, plotted on charts, and used to derive drift rates for the different currents, which is what I've done, but I'm not going to bore you with those technical details. But I must say it's an enormously time-consuming process to select, fiddle with, and composite the images, but certainly not as much time as Slipher would have had to have spent in the 1950s at the Lowell Observatory. Here's a comparison of 2 years. If you have a look at the Lowell Observatory Bulletin, which is available at their website, a recent one, I've got a short article about this process, and this compares 1949-1950, showing how much more colourful the planet was in the former year than the latter. And one almost final thing that we were able to do, and that was to produce the first colour strip map of Jupiter. This is the earliest strip map that's ever been made of Jupiter. You will see it's not quite 360 degrees. We didn't quite manage that with the negatives on hand, because when you're doing a strip map, you've got to do it over a very limited number of days. Otherwise, the two systems of currents, the system 1 and system 2, which relate to the equatorial and the outside of the equatorial region, they begin to differ too much in longitude if you go more than a few days. But we managed to do this, and this is largely the work of Manos Cardesis, as I said, who's produced this lovely colour strip map. So one of the earliest strip map produced from photographic images. And just some very recent work that I was doing only the other week. Here's the best printed copy I can find of a photograph of Jupiter in 1956. And you might say that's not very good, and it isn't. And this is taken from Slipher's book. You can just about make up where the red spot is in its bay in the south equatorial belt with a white oval above it. So what we've done on the next slide, we've taken the plates from that date, the yellow plates, the red plates, the blue plates, and I said to Manos, I don't think you can composite it, because here Slipher has taken his time changing the plates. I don't think you'll be able to produce a result from this, and of course Manos took that as a challenge, and he was able to produce a beautiful colour image of that. You can increase the intensity of the colour if you wish, but you then begin to see a few radial defects in the images. But nonetheless, I just wanted to share some of these results, which is ongoing research, with you, and to encourage anyone who has an interest in planetary or other photographs, it could be deep sky, to go back and see what you can do with some of the images of the past. It's been great to be back in person and to see the whites of people's eyeballs as an ex-teacher. And I must say that webinars, by contrast, is about as exciting as talking to a piece of wet cardboard, and certainly better in terms of audience reaction. So good to see the BAA back in action. And as far as this talk is concerned, watch this space, there'll be more to come. I won't take questions, Mr. President. Thank you very much.
Thank you very much, Richard. That's really attractive and interesting. We have another section director to speak to you next, another of the planetary sections. Dr. Paul Abel is director of the Mercury and Venus section. He'll also a well-known TV personality, of course.
Not so much these days.
But not so much these days. It's out of fashion. And Paul is going to tell you about some recent observations of Venus.
Thank you very much, David. Yes, I'd like to join Richard McKim in saying how lovely it is to be back doing live face-to-face meetings. This is actually my first astronomical meeting it's got to be nearly 2 years now, although I've been teaching face-to-face at the university for the last 4 weeks. It's nice to be doing an in-person meeting again. I just hope I can remember how to do it. So, what am I going to be talking about today? Current observations of Venus during the eastern elongation. So, you may have noticed Venus low down in the evening sky. At the moment, it is quite low, but that hasn't stopped a lot of people observing it and sending their observations in to me. Before we get on to that, though, I thought it might be useful to have a little look at the orbit of Venus. The inferior planets, Mercury and Venus, have very different behaviour in the skies compared to the superior planets, Mars, Jupiter and Saturn. For example, when we had the Mars opposition last year, it was possible during wintertime when Mars was well placed to start observing it early evening and go right through on till 2, 3 in the morning and catch your death of cold and get your eyes frozen to the eyepiece. All of that wonderful stuff happened to me. But it's possible to do a very long observing session. That's not the case with Mercury and Venus because they're much closer in to the sun than we are. And so as a result, they're only ever available in the morning sky. So after midnight, sort of 3, 4, 5 in the morning, and then visible during the daytime, or else they're visible in the evening sky and set before midnight. And this is the reason why. I'll probably illustrate it on this one. I think there's a little point here. So I've got a rather crudely drawn a schematic of Venus's orbit. This is also true for Mercury as well. So we have the sun in the center. You have to kind of imagine the Earth is here. Do it on this side as well. So we've got the Earth here, and we're looking in towards Venus. So we have the sun here, and this is kind of where Venus was early on in the year. So when it's behind the sun like this, on the other side, we say it's at superior conjunction. And then you can see, as Venus moves around in its orbit, two things start to happen. First of all, the apparent diameter of Venus starts to increase, and also the phase starts to decrease. So here it's very full, then it becomes a gibbous. Round about here, it appears as a half moon type phase. We call this dichotomy. Eventually, it comes down to a crescent, and then we have inferior conjunction when Venus is effectively between the Earth and the Sun. And this is when the planet's on this side of its orbit, it appears in our evening skies, and this is called an eastern elongation. And an elongation lasts from position 1 to position 5, in other words, from one conjunction round to the other. So what will happen is that early next year, we will hit inferior conjunction, and then Venus will appear in the morning sky. It will start off as a thin crescent, become half illuminated, and then eventually work its way right back round to position 1. Why is this important? Well, because when Venus is around about this position, all sorts of interesting things start to happen. And in particular, as we shall see shortly, there's all sorts of imaging and new things that can be done with Venus that are really changing the way we kind of think about the planet. Okay, so some upcoming dates that we have. So as I mentioned, superior conjunction, that's this point here. So point number 1 on the orbit. That occurred on the 26th of March, 2021. And since then, Venus has been kind of along here in its orbit. It's now coming up on the 28th of October to theoretical dichotomy. So it should, in theory, appear as a half moon in the telescope or binoculars. It actually wrote, for reasons that I'll go into in a minute. Greatest eastern elongation, in other words, when it's at its furthest distance from the sun in the sky, occurs the day after, greatest brilliance on the 9th of December, and then we hit inferior conjunction on the 9th of January 2022. So Venus is very currently low in the sky. If you have a garden which has trees at the bottom, houses nearby, or lampposts, even if you have a road nearby with large vehicles going on, you're likely to have missed it because it is incredibly low in the constellation of Sagittarius. And what we have here is just a little plot showing the date versus the altitude. So we have date along the bottom and altitude along the top. And you can see here, as we go along, Venus is kind of languishing very, very low in the sky. But as we come towards November and December, it climbs a little bit higher in the sky, and so will be easier to observe. So this is kind of like a good time, really, to start observing Venus. You can find it in the dusk sky, early evening, and around this sort of time, it will be very well placed, well, reasonably well placed, before it drops right off down because it comes into inferior conjunction. So some recent observations, I'll start with some of mine, and these are all I really have. It's because the planet's been so low down, I haven't really been able to make very many of them. I tend to use not just white light with my telescope, I use my 8-inch reflector in general to make observations of Venus because it's very well situated in the garden for me. It's about the right sort of aperture, and I tend to observe Venus during the daytime. There's two advantages to doing this. First of all, you can actually see it. It's not hidden by trees and low down. And secondly, Venus is very, very bright object. So if you observe it during the daytime, it really does, the brilliant sky glow of the daytime sky really does reduce the glare from the planet. It does make it a lot easier to see any of the surface, any of the cloud features. So you can perhaps see some in this drawing here. I've got these vague cloud streaks. It's certainly the case that markings on Venus are very difficult to see visually. There's a reasonable amount of evidence to show now that you have to be sort of sensitive to the bluer end of the spectrum, in other words, more sensitive to blue light, short wavelengths, to be able to see them. But when you do see them, they kind of have these dusky, shady appearance like this. I've got in this drawing, I've got a cusp cup at the top here, got these bright polar regions. I often use different filters. I would encourage anybody who has a telescope to use them. They come with most telescopes. You'll find these sort of round circular filters that you screw into your eyepiece. There are lots of different colours. And the reason they're very useful is because they allow us to see into different depths of the atmosphere. So the cloud patterns do appear to shift if you go, say, from a red filter to a blue filter. It's not just been me making observations visually. We also have Chris Nuttall from York. This is one of his. Again, Chris observes during the daytime, just like me. He's nicely got the blue sky on his drawing, whereas I've got a black outline on mine. But you can see the same sort of thing. You can see these sort of vague shadings and markings. And here we have another observation, I think, by Dave Bassey in Norfolk. And he's not only drawn on the cloud formations here, he's also put some intensity estimates on as well. And that's another thing you can do, is to track how the cloud markings change and how the features in general change over time. But being visual, it is a little bit more limited because the features are quite hard to pick out. However, if you've got access to imaging, then you can do quite a bit more. And this is, these are some infrared and UV images. Because, as I've said, people with the bluer end of the spectrum are more sensitive to the bluer end can see pictures. There's a reason for that. There's a reason you can see more detail on clouds in Venus if you're more sensitive to the blue colours. And that's because the markings in Venus's clouds are very, very striking in UV. Much more so than in infrared. So anybody who uses imaging with a UV filter will capture some really quite interesting details. We've got here a couple of images. So this one is on the right-hand side here is by Rick Hill, and you can see he's been using a UV Barda filter. And you can see the same sort of things. The image quality perhaps isn't great because he had poor seeing, but you can see the same sort of thing. We've got the cusp bands here, and we've got the shaded sort of markings. People even further south have been able to capture some really quite striking details. So we've got this nice image here. You can see some really striking details here. And you can see this one, that this is a GIF image, so several images together. So this is this one here. You can see the cloud formation slowly rotating. Okay, so this is quite an impressive image. And this is the sort of thing amateurs are able to do now with UV imaging, not just image the clouds, but take a series of images of them, and you can paste them together to get this kind of moving. So this image was taken in New Zealand, where Venus is much higher in the sky with a C14, and you can see you get some very, very nice features coming across. Okay, so coming up, we've got some interesting things to look forward to. The first one is dichotomy, and I said to you a little while ago that this apparently occurs on the 28th of October. In other words, it should be the case, if you go outside and the sky is clear on the 28th of October, that Venus will look something like this in your telescope. It will sort of have this half-moon appearance. However, that's not actually the case. In fact, Venus will appear 50% illuminated before this date because of a phenomenon known as the Schroter effect. It was first observed by Johann Schroter many, many hundreds of years ago. It's also known as the phase anomaly, and fundamentally it means that the observed phase of Venus is always slightly less than the predicted one. And you can see this effect for yourself with just with the unaided eye or with a telescope, but it's even more pronounced in filters. So, for example, if you were to use a violet filter visually, a Raton 47, put that onto your eyepiece and have a look at Venus, you would see there would be a real difference in phase between that was predicted, say, in the BAA handbook, and the one that was you actually observe. So this means that eastern or evening elongations, dichotomy is earlier than the predicted date, and western elongations, these are morning ones, a dichotomy occurs later on. So if you want to catch Venus at dichotomy, one of the things we like to do in the section is to try and work out in each elongation when dichotomy actually happens. In other words, when it actually appears to be 50% illuminated rather than when it's predicted. Because this can tell us a lot about the atmosphere of Venus. If it occurs much earlier than usual, then maybe something interesting, something unusual is happening in the atmosphere. So one of the things you should do is perhaps start observing maybe even a week before the theoretical dichotomy. Visual observations are actually best for this, and that's not me saying that just because I'm a visual observer with a degree of bias, but you can see why that might be the case. If we just go back to these images here, you can see the terminator in the images of Venus is very, very diffuse. It's very, very hard to pick out what the kind of phase is here. You can see there is a phase, but it's all quite a little bit blurred and indistinct here. And that's an artifact of the imaging. So in actual fact, it'd be very difficult to tell from an image whether Venus was at 51% or 48% illuminated. So this is a job really for a pair of eyes at a telescope. All you need to do is look, start observing a week before, and keep observing until you think Venus is actually precisely 50% illuminated. Then all you have to do is note down the date and time, the telescope details you used, and then send that observation to me, and that will be incredibly useful for determining the date of when dichotomy occurred. What else is coming up? Well, as we move from Venus being 50% illuminated, it becomes a crescent, and then we have a really interesting phenomenon. And this is stuff that's only really developed in the last couple of years. We can now start to image the night side of Venus. Okay, now this can only be done with imaging and with infrared filters. So Venus's surface is incredibly hot and the night side glows, and if you put on the right sort of infrared filters, you can capture the infrared surface glowing. It's perhaps not come out quite as well as I hoped on this, but you can see we've got the brilliant crescent here. This is a Frank Melilio image from New York, and you can perhaps just about, you see that? Can you see the? You can make out the mottlings here. This is the surface, the unilluminated surface in infrared. It's not available visually. You have to use this infrared filter. Now, how do you do this? That's a very good question. I'm really not entirely sure because I'm not an imaging person, but thankfully the section has a lot of expertise on this by people who do. So Martin Lewis has written an excellent article in the section newsletter messenger. So if you go online to the section website to messenger issue form, you can download it. This is June 2020. You can download that issue of messenger and you'll find an article in there by Martin Lewis who explains how he goes about doing this. And Martin produces a lot of very good quality images of the night side of Venus. In the most recent edition, Peter Tickner, UK observer, regular contributor to the section, he discusses his attempts. He's been using homemade filters and an infrared pass, I think, to make his own observations of Venus. And he's been using these filters to observe Venus not only in UV but also in infrared. And he's given a nice write-up of the experiments he's been conducting, and he's written that up in the latest issue of Messenger, which should be available to download. It's gone out to members, but section members, but it should be available to download by the weekend. Okay, why would we want to do that? Why are we interested in the imaging the night side? This is, again, this is one of Martin Lewis's images. You can see, I think this is much clearer now. You can see these, the surface, the glowing night side. And these arrows here, these are contrast features. These are mountain ranges that he's managed to capture. One of the useful things Martin often does when he produces these images is go to the WinDuPos, this free software, and he often identifies on his images the features that he's managed to capture. So it's very useful. So why should we want to do that? Well, I think many professional scientists who work on Venus would agree that the planet is almost certainly volcanically active. And at the risk of sounding like a former Mercury and Venus section director, I think there probably are active volcanoes on the surface of Venus. I think this is not unique to me. I think a lot of planetary scientists accept that. We've never caught them in action, but that doesn't mean that they're not there. But we have some tantalizing evidence now from amateur astronomers who may have caught the first active volcanoes on Venus. And this is a series of images. This was published in the journal written up by Richard McKim. This is a series of observations by Anthony Wesley and Phil Miles in Australia. And the bits of interest is this bright point here. There's two things that's interesting. Firstly, the bright point does seem to keep the rotation of the planet. And secondly, it does vary in intensity. So we don't think this is an artifact of the imaging or the software. And it could really be a real possibility that Martin and Phil were the first to capture active volcanism on the planet of Venus. And I think this is a really exciting line of research that the section can undertake. Anybody who wants to spend some time learning how to do this kind of imaging, I think could make a very valid contribution to the work of the section. Although we have new spacecraft and missions going out to Venus all the time, I think the UAE have just announced that they're sending a mission. There's lots of missions planned for Venus. I think in the long term, if there are volcanoes down there, I think it's possible that amateur astronomers might be the first to provide the tantalizing evidence or the smoking gun that's actually there. But I think they're also the best people placed to collect regular observations of them and provide an ongoing narrative of this new aspect of geology on the surface of Venus. So I hope as many people as possible continue with this work and submit their observations into me, and I will continue to write up our section reports and put them into the journal as soon as each elongation is finished. It's not just Venus. If you have any Mercury observations as well, please send them to Chris Hooker, our Mercury coordinator. I'm sure he'll be happy to have them. And let us hope that not too distant future, one of our section members images for absolute definite with no degree of uncertainty at all, an active volcano on the surface of Venus. Okay, that's me done. Now I'm happy to take any questions for a few minutes if we have some.
Any questions?
Yes.
I'm trying to get my...
Oh yes, Nick, do you want to?
I'm afraid something you said there's been niggling with me at the beginning. You said that the theoretical dichotomy and the greatest elongation are on two different days, one after the other, but I'm just thinking mathematically they should be almost identical. Well, identical.
They should be, but they're not because of the dispersion of light in Venus's atmosphere.
Yes, but I assume by theoretical dichotomy you mean if Venus was a smooth billiard
Yeah,
ball.
if it was the moon, essentially.
Yes.
If there was no atmosphere there
Yes.
at all, then yes, the two would coincide. Yeah.
Okay.
Anyone else? Yes, over here, Nick.
I don't know how I got this job.
Well, you picked up the mic and started running.
I'm just curious why you stick to CCDs. Of course, they're very sensitive, but mercury, cadmium telluride, and indium antimonide arrays are getting much more sensitive these days and go further into the infrared. So they would be much more suited to this application.
Are they available to amateur astronomers, though, at reasonable prices?
On a society level, yes. Personal level, probably not.
I think that answers the question then, doesn't it? Yeah, it's entirely based on, I guess, on what technology amateur astronomers can afford. And I suppose that does have to be offset, really, with how frequently they can be used. I mean, this kind of work can only be done when Venus is in its crescent stage. So I can understand if people don't necessarily want to outlay the cost. That said, the results got so far, I think, are pretty astounding. So,
well, the price of indium antimonide and mercury cadmium telluride especially, they've gone down by a factor of 10 in the last 10 years. So they're getting quite affordable.
Well, perhaps
their resolution is going up as well.
Well, maybe you could drop me an email about this and we could put this in the next edition of Messenger and we can see what amateurs think about using that.
Yeah, I mean, you would need to persuade a camera manufacturer to make a camera that was accessible to an amateur, because people aren't just going to buy a sensor and build one. I mean, that's just not going to happen.
Okay, anybody else? I think that's about it.
I would add to that, on the subject of the expensive equipment, it is one of the things the BAA can do in some cases, is to subsidise equipment where amateurs need expensive things. We have grants for that purpose, and indeed Martin Lewis, who's referred to in this talk, did benefit from a Ridley grant from the BAA to help him buy camera and filters specific to the task of imaging the night side of Venus. So when new technologies come along, which may be a bit too expensive for people, we can help with that. So it's a good suggestion. It's worth thinking
We
about.
got the grant out very quickly. If you remember, David, he applied for it and was using it 3 weeks later, in time for Venus. So.
Occasionally, the BAA can do things quickly.
Occasionally.
There's a question that's come in on YouTube from Daryl Dobbs. He says, do you think it's worthwhile observing Venus in the ultraviolet?
Yes, absolutely. That's where the cloud formations are. It's also, I haven't had time to mention it, it's not only in ultraviolet, but in infrared. We saw a very interesting phenomenon known as the wave phenomenon, this long wave that apparently manifested itself in Venus's atmosphere. That was only visible in infrared. Why? I'm not entirely sure. So it's well worth, if you've got an infrared or UV filters, to continue to make observations in that, and I'll be very happy to receive them.
So that appears to be all. So we'll thank Paul again and look forward to more exciting results on Venus. During this first meeting of the session, traditionally the new president doesn't do that much, apart from introduce himself and tell you about forthcoming events. But I thought I would change that. I thought I would give you the sky notes for the next month or so in the concluding part of this evening. So these are the sky notes for October to December. And I thought I would start with novae. There have been a couple of novae. And this is called V1405 Cassiopeae. And according to Jeremy Shears, Nova Cass 2021, it was discovered on March the 18th, and it's keeping everybody on their toes with re-brightening episodes. And he says, take a look at its beautifully intricate light curve attached. He might call it intricate. I might call it chaotic. But it's still very bright, 7th magnitude, so it's a binocular object. Hopefully it will continue to provide a spectacle into the autumn. And here's another one. We've had an eruption of RS Ophiuchi on August the 8th, and this is a recurrent nova. It erupted in February 2006, and it's now gone back to quiescence, but it needs continued observation. Is there a pointer?
It's the middle button.
Middle button.
Yeah. Don't blind your visual observers, though.
Oh, yeah. Okay. It's been reported recently that the flickering has ceased during September, so the theory behind this is that it had an eruption on August the 8th, and that perhaps disrupted a disk of material around it, and that's why its light has become more constant, and that's what happened in previous occasion in 2006. But following that, the accretion disk seemed to have re-emerged after 240 days. Looking further out into the universe, here's a supernova, an interesting supernova, SN 2021 ZNY, discovered on the 22nd of September by the Zwicky Transient Facility. And here you have an image and a spectrum by Robin Leadbetter. And he's written this on the BA website about this. This type of supernova, this type 1a SC, is very rare, and they have been considered to involve an explosion of a progenitor star which is more massive than it should be. It's more massive than the mass it should be able to achieve according to the Chandrasekhar limit, which normally determines the mass at which a supernova explode, the normal type, type 1a, but that's by no means certain. There are other scenarios that have been thought about. And so this spectrum was taken 3 weeks after discovery, and it's at mag 16, and Robin was using an LP200 spectrograph, and he took 3 nights observations and combined them together to improve the signal to noise ratio. So he's doing very impressive work on that. Let's move on to the outer solar system. And it's a good time for the outer ice giants. They're quite well placed. Neptune is now transiting in the late evening. It's magnitude 7.8, and it's 24 degrees high. And recently we had the 175th anniversary of its discovery, which was September the 24th, 1846. And so there you can see Neptune is between Aquarius and Pisces. Here's an image of Neptune. You can't see much, perhaps a little bit of a white patch there. But in the past, Neptune has shown spots which are observable with amateur equipment, so it's well worth keeping an eye on. Here's another image by, this is Christophe Pellier, very well-known amateur imager in France, and this is a tiny thing, and of course it is a tiny thing. Perhaps a little bit of brightening there on one side, but not a lot of detail. Uranus will shortly be at opposition, 4th of November. It is between Cetus and Aries. There it is. Magnitude 5.7, so it's just within naked eye reach if you've got a good sky, and it's nice and high up, 53 degrees high at midnight. Generally, in images and drawings, all Uranus rather, shows is this slight contrast between the two hemispheres, the bright northern hemisphere and slightly darker southern hemisphere. And of course, it's on its side because of the extreme angle of the poles. So you have to take that into account in deciding which is north and which is south on Uranus. And here's another image, again, one from Rick Hill. Paul just showed some of Rick's images, which were all taken with quite a small telescope, but he's very persistent with his 8-inch Maksutov Cassegrain, and there is Uranus. And again, you can see this slight contrast between the two halves of the planet. If you expose for longer, you can detect some moons. Here's an image from Denis Basinski, and he was using a Celestron 14-inch and an ASI camera, ASI 1600 mm camera, and the exposures were 3-second exposures, and he was able to record 4 of the primary satellites. One of them was too faint for the exposure used. And he comments that this was 240 years since the discovery. And Uranus in that time has done 2.8 revolutions around the sun. And the magnitudes which he has measured, they're of the order of 13, 14. Where are we? And, I missed one out. Kevin Bailey took this image, and this shows Miranda as well, faintly. There's Miranda, and he used quite an old digital camera for this, a Leica compact digital camera, and don't know what the telescope was, doesn't say it there. Moving further into the solar system, giant planets, very beautifully on show at the moment. They are in the evening sky now. Saturn is now transiting at 7:30 BST, rather low, 19 degrees high, and Jupiter's following on about half an hour later, slightly higher, 23 degrees high, and a lot brighter. And here's some recent images of Saturn, a compilation, and there are a number of spots visible, particularly in this very enhanced monochrome image by Trevor Barry from Australia. Of course, in Australia, the planet is much higher, so much higher resolution is achievable. And but something is achievable in this country. Martin Lewis in St Albans has got a pretty sharp image there. So the features on Saturn generally are subtle white spots and slight indentations, slight crenellations of the belts and zones. But Saturn is moving into the sunset now, and we'll soon lose it. But we've still got Jupiter, and here's a lovely image by Peter Edwards. Even a Jupiter 23 degrees high. It's really quite amazing what our images can do now. And this was taken on the 23rd of August. And he's in Sussex. And that was a Celestron 14 telescope and a ZWO ASI 224 MC camera, for those who are interested. And an image again from Sussex. This is Damien Peach in Sussex. And he's caught a nice view with the GRS there. Yeah, I'm trying to change them so that I don't have to, look around there. So I'm trying to change them in sequence on my machine as well. So this is Damien's picture, lovely view of the Great Red Spot, been contracting recently, growing more intense. I don't quite agree with what Richard said, that it was more spectacular in the past. It was bigger in the past, but it was pale in the past. These days, it's really intense. And before lockdown, when we were able to do public observing, and I was showing Jupiter to public, people who'd never looked through telescopes before, at the events that the Baker Street Irregular Astronomers held in Regent's Park, I was finding that just people coming up and looking through my 4-inch refractor were able to see the Great Red Spot. Because they needed pointing out to them, but once it was pointed out, they could see it because it is such an intense colour. Again, Martin Lewis doing sterling work. Here's an image with the methane filter. The methane reveals the higher altitude features, so the white spots are high altitude clouds, essentially, or their weather systems throwing up higher altitude clouds. And here's one of my images. It's one perk of doing the Sky Notes. You can put a lot of your own images in if you want to. This is the kind of result I've been getting recently. On the left, there's the infrared image. Infrared tends to still the seeing somewhat and make the image a bit sharper. And then I've got the red, green and blue combination of filters taken with a monochrome camera. And in the right-hand side, I've combined the red, green and blue with a luminance layer of infrared, and that gives a somewhat more contrasty and sharper image, but at the expense of distorting some of the colours. It's very characteristic of Jupiter at the moment that it has this lovely orange hue in the equatorial zone, in the northern part of the equatorial zone, and you can see that quite prominently visually, or at least I can, but that is rather distorted in the false colour version with the infrared in there as well. So these different presentations show up different real features. But Jupiter's been doing some flashy things. Impact flashes have been recorded, and here is a still from a video taken by Jose Luis Pereira in Brazil, processed by Marc Delcroix in France, and this shows a meteorite impact, or some kind of object impacting in Jupiter's atmosphere briefly for a few seconds. These flashes appear for a few seconds, but amateurs, particularly a French group of amateurs, has developed some software called Detect software, which can be used, the video can be run through this software and it will detect flashes which are suspicious. And the software detected this example, and this is a flash which appears for a couple of seconds maybe at most, then disappears, then it's left no apparent trace in the atmosphere of Jupiter. But it's very interesting to see how often these occur. And we only started to be able to see these, to be able to record them about 4 years ago. And since then, there's been quite a few seen. And in the last couple of months, there's been 2 occurred. This one occurred on September the 13th, and another one then occurred on the 15th of October, and that was observed by a man called, or an observer called Ko Arimatsu at Kyoto Observatory in Japan. This is not his image, I haven't got his image, but I've shown here an image from the Juno spacecraft, because it just so happened that Juno was scheduled to pass over the very area of Jupiter just a few hours later. And so this is really interesting. This was the first occasion when we could get an image from Juno of an area of Jupiter that had been struck by an object which had been seen as this flash from the Earth, and we could see, has it left any evidence? And this is a composite of images put together by Shinji Mizumoto, and what you see here is the JunoCam image from the spacecraft, and this is a composite of amateur images. This is a map, ground-based observational map. And one thing I'll point out to you, see, when you see this in the JunoCam image, this is not Jupiter, this is not the limb of Jupiter, this is the horizon of Jupiter as seen by a spacecraft only a few thousand miles above the cloud tops. So what you have here is the North Equatorial Belt, North Temperate Belt. This is the North Equatorial Belt. This is this anticyclonic wide oval there is there, and this darkish barge is there. So what you're seeing in all of this is like a small circle like that on this map. So that shows you what's happening with JunoCam, that the horizon is so restricted and it goes in really fast. And this is an important point because this is the strength of the Pro-Am collaboration, which the NASA is very keen to foster, and they've been meeting with amateurs regularly online throughout the pandemic period to get amateurs to keep observing the planet and producing these maps. So they have the overall picture from the amateur images taken all around the world, and they can therefore know what the context is of these very small horizon limited shots that the Juno spacecraft is able to capture. So the final conclusion from this, or the preliminary conclusion, is that there's nothing there. It should be there. That was the area where the impact occurred. There's nothing there. This awaits the final higher resolution images, which will be processed eventually. But according to this preliminary analysis by John Rogers, there's nothing there. So that's interesting, that an object that's bright enough to create, big enough to create a flash seen for a few seconds from Earth, still just disappears into the sea of Jupiter's deep clouds. What else has the Juno cam been seeing? Well, it's seen a new STB outbreak, and this, John Rogers' comment, is rather similar to the spot discovered by Clyde Foster, who's a BAA member, very enthusiastic BAA member, who works from South Africa. That he discovered a feature like that last year, known as Clyde Spot, and this seems to be a new outbreak of the same type, and it seems to be producing a series of little spots being spun off again. So this is interesting to see another similar feature in the Juno cam images for the first time, behaving like Clyde Spot of last year. And John Rogers has named this new outbreak in the STB as Spot 8, but perhaps we need to find a better name for it. And on perigeo 35 and 36, Juno cam had a good view of the polar areas, and here's a combination of those images on those two passes done by Gerald Eichstadt, and he's a very interesting character. He's really done so much work for NASA in an amateur capacity in developing the software to analyze these images and put them together, which is a complicated process because the spacecraft is moving and it's taking red, green and blue images all the time, but he's getting slightly different views in the different filters, and he developed this software to combine them. And this is all amateur work that's going into producing these really amazing results from the Juno cam images. So this is a fantastic pro-am collaboration on several levels, both the direct observation using Earth-based telescopes and the work on the software and the work on the processing, which anybody can do. Anybody can download the raw data from the Juno cam and start working on it. So that's enough of the giant planets. Let's talk about the terrestrial planets. Here's our lovely moon, and here's the phases of the moon. And it's next new on November the 4th, and next first quarter, which will be rather a low first quarter, and November the 11th. The next full moon will have an eclipse, more of that in a moment. Last quarter, November the 27th, that'll be a nice high last quarter, a good observation, a good opportunity to observe the moon in the early morning, if you care to do that kind of thing. And then a solar eclipse on the 4th of December. Unfortunately, these eclipses are of little more than academic interest to us. The partial lunar eclipse on November the 19th is visible in North America. But it occurs at moonset from the UK, and the moon has hardly moved into the umbra at all. By the time the moon sets in the UK, it'll be too low, so you're unlikely to see anything at all from the UK. It'll be a very challenging observation to see anything. Then the total solar eclipse of December the 4th will not be seen by many humans. It will be seen by the odd penguins. Are penguins northern or southern hemisphere? Southern. So it will be seen by penguins who will no doubt write a paper on it and submit it. for the BAA. So it's just visible in Antarctica. Well, we've just heard a lot about Venus. As we've just heard, it reaches greatest eastern elongation soon, but it's in rather a southerly part of the sky in Sagittarius or Ophiuchus, so it's rather low, and although it's bright, magnitude -4.4, it's only 8 degrees above the horizon at sunset. If we wait until slightly later in December, it has a slightly higher peak altitude at sunset. It gets up to 13 degrees, but it's not a good apparition for us, not a good elongation for us. But here's an image from the previous morning elongation, which may have already been shown by Paul, another one from Rick Hill with his 8-inch telescope and the ultraviolet filter, and you can see the characteristic cloud pattern there, this characteristic reversed C-shaped pattern. Mercury is in the evening sky. No, it's in the morning sky soon. Greatest western elongation. October the 25th, so it's very shortly. It'll be quite bright, magnitude -0.6, 50% phase. So this is one of the better occasions in the year to catch Mercury in the morning sky with the naked eye. And here's a fairly recent observation of Mercury, which a lot of imagers are now doing. They're imaging Mercury in the infrared, and the conventional presentation is that you get the image here, and here is a simulation based on the space probe Mercury Messenger images, and you can see there's considerable correspondence, and this is achieved quite regularly by a few observers, by Simon Kidd amongst others, and Martin Lewis, and a few other UK observers are quite regularly able to image real features on Mercury. We don't think the features on Mercury change at all because there's no apparent activity and no atmosphere, but it's an interesting demonstration of what amateurs can achieve. And it's better than going down the pub, maybe. Maybe that's a matter of taste. The Mercury's been visited by Bepi Colombo, European spacecraft, arrived there on 1st of October. It hasn't stayed there. It's moved on. It hasn't been inserted into orbit around Mercury. It's taking a leisurely stroll round the inner solar system. It has to pass Mercury 6 more times before it's finally slowed down enough for it to be inserted into orbit. It's quite difficult to send a space probe into the inner solar system because obviously there's a danger of falling into the sun, so it has to go via a lot of other planets in the meantime and go round a few times, and eventually it can be put into orbit in a couple of years round Mercury. But there's an image that Bepi Colombo has taken. Bepi Colombo is going to study the geology of Mercury and also its magnetic field, its magnetic interaction with the solar wind, and attempt to solve the mystery of why Mercury has such a strong magnetic field for such a small rocky planet. I'll move on to the minor bodies of the solar system. One of the brightest asteroids, Ceres, in fact it's classified now as a dwarf planet, Ceres, is very close to Aldebaran on the 3rd of November, so that should be an interesting observation. It's just 0.5 degrees south of Aldebaran. And a few weeks later, 27th of November, it reaches opposition, and it will then be 8th magnitude. And here we come to my comet, 67P, Churyumov-Gerasimenko. It's, of course, a famous comet because we know a lot about it, because the Rosetta probe visited it. It's very well placed in our sky. It's in Gemini. It's visible most of the night. Mag 9.8. Peter Carson's taken this lovely image from his observatory in Essex. and he's kindly provided me with images of all the brightest comets that are visible currently. Here's another image, and that colour one, of Churyumov-Gerasimenko. Getting better at that. After 2 years, I'll have it off. And this is taken by Peter Tickner in Berkshire, who's one of our most prolific imagers of all kinds of objects. I had the privilege of meeting him just last week when I gave a talk to the Reading Astronomical Society. And he's been doing fantastic work on the planets as well. So there's a colour image of 67p. 29p, Strachman-Wachmann. We've got all the good names in the sky at the moment. That's well placed as well. That's in Aries, mag 10.4, and it's been outbursting. I'll say a bit more about that in a moment. Also, Comet Atlas 2019 L3, that is circumpolar in Lynx, another Peter Carson image, and that's... Sorry? Out of sync. There is Comet Atlas 2019 L3 in Lynx, and that's best seen before dawn. But quite a lot of interest in this object, 2021 A1, Leonard, an easier one to say. It's faint at the moment, only about 12th magnitude, but it may get brighter, and if we watch it into December, it will move, moving quite rapidly across the sky. At the moment, it's currently somewhere near Ursa Major, and it's going to move quite rapidly eastwards. So it could brighten up, so well worth keeping an eye on Leonard. So, Strachman-Wachmann, we've got a special project which is outlined on the BAA website to observe it. It's, according to Richard Miles, it is the second most active body in the solar system after Io. It's locked in a near-circular orbit between Jupiter and Saturn at 6 AU. Never approaches the sun closely, doesn't have a tail, but we want to make it the most observed comet and improve our understanding of it. It's had an outburst in September, brightened up quite nicely, there it goes. And here's some pictures before and after outburst by Richard Miles, taken with the Falk's telescope. That's the light, that's the light curve. Sorry about that. And that's the comet itself. Here's another one of the comet in colour. On the right-hand side, it's in colour. Peter Tickner took that one. And left-hand side, it's one of Richard's images. And Richard says this indicates there's an excess of blue light in part of the image. In the excess of, so that's the excess of blue light. Might indicate ionized gas moving in that direction and overtaking slower moving dust. And an even more spectacular outburst here. Richard reckons this is a quadruple outburst, which he imaged with the Falk's telescope on 30th, I think, 30th of September. So a lot of activity with 29p, Strachman-Wachmann. Meteors. And comets, of course, in due course, will disintegrate to produce meteor showers. Here's the upcoming meteor showers. We have the Orionids, which is going on at the moment. It's past its peak, but moonlight is interfering. We've still got a bright moon in the early morning sky. Then we've got famous shower in November. The Leonids is not particularly predicted to be spectacular on this occasion. It's not one of those years when we pass through the main part of the meteor stream, but it should have a ZHR, zenithal hourly rate, of about 15. But again, there's some interference from moonlight. Geminids, the most famous, one of the most famous showers of the year, certainly the most intense shower of the year in recent years, occurs in early December, maximum on December the 14th. Could be 100 meteors an hour at least. Unfortunately, moonlight interferes with that one as well. What's the sun been doing? It's been waking up. There's been a few sunspots. In fact, at one stage in September, there were as many as 4 distinct groups, and here's an image taken by Kwong Man in West of London Astronomical Society, taken with his 70mm refractor and a white light filter and an ASI 174mm camera. Since then, some of the spots have rotated round, disappeared, but we still have one prominent active area. We've had one prominent active area in the last week or so. This is called AR 2882, and here's a nice hydrogen alpha image taken with a 70mm solar scope by David Strange, showing that spot. And here's a more close-up version. This is from Luigi Moroni, contributor in Italy, October the 9th, and this is with a bigger telescope, 152mm refractor, and a day-star chromosphere, 0.6 angstrom filter. And when we get sunlight, of course, we get weather phenomena. And here's a nice weather phenomenon. We don't generally deal with meteorology much in the BAA, but I was sent this attractive picture of a rainbow, which Janice McLean captured with her iPhone in Northumberland, near Beadnell, on the 29th of September. And I actually got a double one just a few days later. That's one I took from Harrow. That's one I took from Harrow on the 3rd of October on a cycle ride. We got rained on and we waited in a bus shelter. And I took that photo of a double rainbow. There must be some explanation. I'll have to ask somebody, or somebody can tell us. Somebody can tell us why one sees other colours beyond the violet part of the rainbow.
You can look it up, but there's various dark regions inside the arc and outside the arc. It's all to do with the way that the water is refracted and scattered by the raindrops.
I found that quite striking on that particular occasion. But luckily in this country, we don't have this kind of thing. This is obviously La Palma and the erupting Cumbre Vieja volcano. Paul Leyland's observatory is uncomfortably close, and sadly, one major amateur observatory has already been destroyed by the lava flows from this volcano, tragically. But Paul Leyland is still okay, so we hope that his observatory will be unscathed, but all the telescopes on La Palma, I think, are closed up, really, partly because of the earthquakes and partly because of worry about the ash getting into equipment. So next time you curse the bad weather, light pollution, bad conditions in this country, just maybe congratulate yourself on what a good choice you've made in observing from England's green and pleasant land. Here's England's green and pleasant land, a very pleasant place. This is Kelling Heath in Norfolk, where the recent equinox star camp took place. And I took this picture looking towards the sea, looking towards Weybourne in the distance. There's the windmill there, lovely view. And of course, lots of telescopes there. Interesting double binocular telescope, 7-inch Maxitov telescope, and I'm getting him to write an article, hopefully, for us about how he constructed that. And also took this picture of a sunset over Kelling Heath, and that's the steam train that runs past there. You're always seeing this puff of steam around there. It's not so luckily that's not volcanic eruption. That is the steam railway, the Norfolk Steam Railway, which is another of the delights of that area. And of course, people go there for the darkish skies, dark by English standards, and to mainly observe the galaxies that are visible in the autumn sky. And here's the most famous galaxy in an image taken by Dennis Basinski from north of Scotland recently. Here's his exposure of the Andromeda Galaxy, taken with his Takahashi Epsilon refractor and a Sony A7S camera. So not a specialized astronomical camera, but a conventional consumer camera, and only 15, 30-second exposures in very dark skies. But even in the bright skies of London, I can get something. This is a monochrome image, which I took a few days later. I've got a bit more exposure than Dennis used, perhaps a third more exposure. And this was with a cooled CCD camera, a QSI camera, which has actually been donated to the BAA recently. And I've been testing it out to find out how it works. So when we sell it, I can tell whoever it is how it works. And I also took this image with this telescope, with that telescope, the telescope that's been donated to us, and that camera. And this is the Heart Nebula in Cassiopeia, IC 1805, and that's only 220-second exposure. So it's only 4-minute exposure on the Heart Nebula through a hydrogen alpha telescope. So these narrowband filters in very light polluted locations like London, my observatory is in outer London, it's only 9 miles from here, it allows us to see these emission nebulae, or to observe these emission nebulae, which are such an attractive feature. Another attractive feature of the winter sky is the clusters, the Messier numbers, roughly 35, 36, 37, around Gemini and Auriga. And here's another Dennis Brzezinski image, 6th of October of Messier 35, with his Sony A7S camera. And it says here, Nick James stacking software. So I don't think that means that Nick James has got a job stacking crates of software somewhere. I presume it means that Nick James has developed his own software, which has been used for stacking images. So incredible. Yeah, so no doubt he'll tell you more about that if you want to know. But I couldn't resist putting in this image, which has been uploaded to the BAA website. Isn't that amazing? The Dolphin Nebula, Sharpless 308, imaged by Nick Szymanek with a remote telescope system. The remote telescope is a 500mm, half-meter telescope in Chile, and with an FLI CCD and with a lot of different filters. He's used the Telescope Live remote imaging platform, but that is fantastic. That's in Canis Major, so it would be visible from this country, but I don't know how good a result you'd get from this country because it wouldn't be very high. The last part of my talk, I thought I might call slightly delayed or lost in the post. You will have heard earlier in the meeting complaints about journals being a week late or something like that, and we often get complaints that, oh, the BAA reports things too late or takes too long to publish things. Well, here's an image that's 50 years old, has just been uploaded to the BAA website. Hugh Phillips, whom I don't know, but I very much congratulate him on doing this. He took an astro image in 1971 of the partial solar eclipse, and it was his very first astro image taken with a Praktika Nova camera on 35mm HP, maybe is that, on some side of film, HP3 film, and I had a Praktika camera just a few years later, so that rather resonates with me. They were very good cameras made in East Germany, very solid. You could drop them on concrete and they would survive, and mine still works. So he decided to upload this image to the BAA website 50 years later. So that's great, isn't it? And I think we should all do this. We should all look up our first astronomical image or drawing, scan it in, put it on the BAA website. We could have a festival of old images. I think that would really increase our esteem in the astronomical world. But if you think that took a long time, here's another interesting thing on the BAA website at the moment. This is a postcard, and David Strange at the Norman Lockyer Observatory reports that this postcard was sent 100 years ago, in 1921, and it's just been delivered to the Norman Lockyer Observatory. So it's addressed to Major William Jim Lockyer.
It doesn't have a postcode.
Doesn't have a postcode, but it's got basically the correct address, the Hill Observatory, Sidmouth, South Devon, which is where that observatory still is, which is now a public facility where David Strange volunteers and looks after it. And this was originally sent by a Japanese astronomer, or a librarian, in fact, librarian of the Science College of the Imperial University, Tokyo, addressed to Jim Lockyer, 1921. And here is the obverse of this postcard. The postcard acknowledges receipt of Lockyer's spectroscopic observations of Nova Cygni, 1920, and a handbook of the Hill Observatory. And we don't know who sent this. It arrived in a plastic envelope inside a letter which had a UK stamp, but there was no covering letter. So did this actually get delivered in 1921 and then go astray and now has been sent again, or did it never get to its intended location? So Nick James, with great enterprise, actually imaged that same object. Nova Cygni 1920 is now known as V476 Cygni, and he imaged it on the 21st. It's quiescent, it's magnitude 18. In the intervening period, it would have thrown out shells of material in its various outbursts, but Nick comments that you would need a bigger telescope and darker skies to see those. So next time you complain about your journal being late, just remember that the BAA could be about 50 years late in publishing your observations, and you could have a postcard arriving from the other side of the world 100 years late, but consider that the universe is 13 billion years old, the Earth is at least 4 billion years old, and in the astronomical timescale, these are just the blink of an eye. Thank you very much, ladies and gentlemen. If there are no any further comments, we'll have to go. I will now close this meeting, and we will reconvene for the Christmas meeting on the 4th of December, which will be at the Royal College of Medicine. Thank you very much, everybody, for coming today.
Thank you. Very good. What about it? Assuming you're still there. Sorry? Oh, do you? What did you